Welcome to the course of Continuous Integration and Delivery with Atlassian Bamboo. Atlassian Bamboo is a continuous integration and delivery software that can automate a software application's build, test, and deployment process. Continuous integration is a software development practice to make sure that changes that are made by different developers will integrate together well. Here are some of the benefits of Atlassian Bamboo. Atlassian Bamboo can provide automated and reliable build and testing process, letting you focus on coding. Bamboo builds and deploys projects which have different technologies, platforms, or target servers. It optimizes the code integration cycle and makes sure you never commit broken code back into the code repository. Bamboo also runs unit tests and potentially performs code quality checks at build time. This image demonstrates that how continuous integration works. Normally, in any given project, several developers work on the source code of the project on their local machines. Every time a developer finishes making changes on their local machine, they commit or push the changes to a source control system such as Atlassian Bitbucket or GitHub. If you have set up continuous integration with Bamboo, Bamboo will detect such changes. And before the local changes are merged with the changes in the source control system, Bamboo builds the code, runs the unit tests, and potentially performs a code quality check. If all these checks are passed, and Bamboo makes sure that the committed change is not going to break the existing source code, allows the commit to be done and the local changes be merged to the code that we have in the source control system. Another job of a build server such as Bamboo is that if we want to deploy the source code to our test environment or to production environment at any given time, Bamboo can again build the source code, run the unit tests, package the source code, and deploy it to the target environment. Before we install Bamboo and use it, let's have a quick look at the architecture of a continuous integration system using Bamboo. So obviously in such a system, we have a Bamboo server and we have Bamboo users. For example, a Bamboo user can be a technology manager or a product manager that wants to deploy the code artifacts into production environment. In this case, they trigger the built-in Bamboo system or server. A build trigger can also be based on a schedule. For example, we can set up Bamboo in a way that every midnight it compiles the code, packages it, and deploys it to our test environment. The process of building and packaging the code doesn't happen on the Bamboo server itself. It happens on a different server that hosts a different software called Build Agent, and Bamboo connects to that server and instructs the Build Agent software or component that what it has to do. The Build Agent then connects to our source control system, for example to Bitbucket or GitHub, and it pulls the source code, then performs building the code, packaging the code, and things like that. At the end, we will have a code artifact. The outcome of the build and packaging the source code is normally a zip file that includes any software that we want to deploy. In terms of deployment model, Bamboo has a web user interface that a user can access via HTTP or HTTPS. And also we need to create a build agent server, as I said before. So on top of the Bamboo server, we need build agent servers as well, and we have to install the build agent software on those servers. One Bamboo server can have many build agent servers. So when a user creates projects in Bamboo and creates configurations for every project, that information is stored in a database. It's highly recommended that you don't install your database on the same server that is hosting your Bamboo software, because if you lose your Bamboo software, you will also use all the data relevant to your projects and build configurations. So it's better that you have a separate server or environment for databases. You can use many different types of relational databases for Bamboo, including MySQL or Oracle. In this course, we will use MySQL because it's free and many of you can basically download it and use it as well. Regardless of the type of the operating system that you use in order to run Atlassian Bamboo, there are 3 requirements that you need to satisfy. The first one is having Java Development Kit or JDK installed on the machine or server that runs Atlassian Bamboo. Don't worry if you don't know Java, all you need to do is to download the Java development kit from the provided link and install it. I will show you how you can do that in the upcoming lectures. The next thing is the database. If you install Atlassian Bamboo on your local machine for the sake of learning or for your home projects, you can use the built-in database that comes with Atlassian Bamboo and is quite easy to set up and use. But if you want to set up Atlassian Bamboo for your team in the company, you need an external database because the built-in database cannot be used by multiple users. Atlassian Bamboo supports MySQL, Oracle, SQL Server, and Postgres. In this course, we will use MySQL. In order to connect to an external database, you need to have JDBC driver. You can download the JDBC driver at the time of installing Bamboo. I will show you how we do that. The last thing you need to have is the installation package of Atlassian Bamboo. You need to head to atlassian.com/software/bamboo and download the installation package that is relevant to the operating system of your server or your computer. In this lecture, we want to install Atlassian Bamboo on a Windows machine. And for that, we need Java Development Kit or JDK to be installed. For that, we can download and use OpenJDK by going to https://www.openlogic.com. Then go to Downloads menu and choose your Java version as 11. Because Bamboo uses older version of JDK, your operating system is Windows. Architecture in my case is x86 64-bit and package is JDK. Make sure you don't download JRE, you need JDK, and click on MSI to download the installation package. Then go to where you have downloaded this package and double click on it. And make sure that you choose this option that says Set Java Home Variable. That will create a system environment variable for you. Bamboo requires this environment variable to run. Now we can download the installation package of Atlassian Bamboo. For that, we go to https://software/bamboo. So right now you don't need to be signed in, but I recommend that you create an account using your email address or using your Google account, or even if you use Mac, you can use Apple ID, and then have that ready because then you will need that account to generate an evaluation license. So just for downloading the installation package, click on Try it for free. On this page, scroll down a bit and click on Check out our download archive. On their latest release, click on Get Started. Read the Atlassian Software License Agreement, and if you agree with it, click on I agree to this agreement and click on Submit. Once the package is downloaded, open the folder, double click on it, and it will install Bamboo for you. One thing that is important is that you should not install Bamboo under a system folder, for example, program files or users or Windows, because then you will have access problems and you will get frustrated. So once we click on Next and it says where you want this to be installed, I highly recommend that if you can, don't install it on the C drive or wherever your Windows is. Click on, for example, D drive and then give it a folder like Bamboo, something simple. On top of that, you also need a Bamboo Home. So Bamboo Home is where the files, the temporary files and configurations are created. I highly recommend that you also go to a drive like D, somewhere that is not used for hosting Windows. Create a folder called Bamboo Home, or let the installation wizard create it for you and then just use that. It should not be under users folder or under program files folder or like Windows folder. Now that the installation is completed, we can close the wizard. Then we can go to where we installed Bamboo. And if we go to the bin folder, you will see that there are some batch files in here. For example, Start Bamboo, Stop Bamboo. To start Bamboo, double click on Start Bamboo batch file and you will see that Apache is launched and it will start listening on port 8085 by default. We can change this if we want, but that is the default port. So now if we go to HTTP localhost on port 8085, we should see Bamboo. If you do this for the first time, it's going to take a bit of time to launch Bamboo. The first time that you run Bamboo, it will ask for a license key. You can create an evaluation license key that will work for 30 days. And to do that, you click on Generate a Bamboo Data Center license, and you need to log in using your Atlassian account. If you don't have one, you can easily create a new account here using either an email address or using your Google account or Microsoft account. So I already am logged into Atlassian account, to my Atlassian account in a different browser. What I need in here is the server ID, and let's go to the other browser that I have open. So this is the browser that I have open, and I am logged into it using my own account. And the first thing I need to do is to put in an organization name in here. It can be anything. So for example, it can be test. It can be any organization. Your instance is not running yet, and you need to put the server ID in here. Then click on Generate License. You need this license key that is in this box. Now we go back to the other browser in Windows. So back to Windows, I just paste that code in here and we click on Continue. And then we will see the configuration page of Bamboo. So I stop this video in here because I'm going to record other videos about installing Bamboo on Linux and Mac. And then I will show how you configure your Bamboo for all operating systems, because it's basically the same for all operating systems. If you are a Mac user, please follow this subject to install Atlassian Bamboo on your Mac computer. To run Atlassian Bamboo, you need Java Development Kit or JDK. Please bear in mind that Atlassian Bamboo works with JDK or Java Development Kit and not JRE or the Java runtime. There are several options for installing JDK. The easiest one is to download and install the OpenJDK. You can go to a website called OpenLogic by going to openlogic.com and click on Downloads. Then in here, choose your Java version. Please remember that Atlassian Bamboo works with older versions of Java, so if you download the latest versions, most likely Atlassian Bamboo is not going to work. So select version 11, because at the time of making this video, Atlassian Bamboo's documentation says that they have tested the Atlassian Bamboo product with the version 11 and they are confident that this version is suitable. So the operating system is Mac OS. The version 11 only works with the Intel chipset, and also you want JDK and not JRE. Then download the PKG or zip file, whichever that suits you. Once the package is downloaded, you can run it. As soon as we finish installing JDK, we need to create an environment variable called Java Home, because Atlassian Bamboo requires the Java Home environment variable to run. So for that, we need to bring up a terminal like the one that I have. There is a special path that if you just type it in terminal, it will give you the installation path of JDK, and that is /usr/libexec and then /Java Home, and it has to be all in lowercase. And as you can see, it gives me the full path of where the JDK is, and we want to use this to set the Java Home environment variable. In Mac, we can edit the bash profile and then add our environment variable to it. There is a text editor in almost all flavors of Linux that is called Nano. We use that to edit the bash profile. And also I recommend that you use sudo. If you're not familiar with Linux commands, sudo basically runs any program that you want as an administrator. So I say sudo nano, and then the file is called bash_profile. And as you can see, it already has one environment variable called go debug and one is called SDK man. These are the environment variables. So we want to create a new environment variable. So just like the other two, we say export and then Java home is all in uppercase. Now, either you can copy paste the long path that we got in terminal, or you can just use this variable using a dollar and then parentheses, and then again say usr libexec java underline home, and then press Ctrl X and then Y for save. That's it. Now we can go ahead and download and install Bamboo. So for downloading and installing Bamboo, we can go to this address. We can go to https www.atlassian.com/software and then /bamboo/download. If you don't have an account, you should create an account. At this stage, you don't need it, but eventually you will need an account in Atlassian's website. So if you don't have one, maybe create one now and then continue. If you don't want to do it now, simply scroll down, find this check out or download archive button, click on it. And either if you want to install this for example, production use the one that has long-term support. Otherwise, just use the latest version. Click on get started. It will identify your operating system, read the license agreement, and then check this if you agree with it, and then click on submit button. That will start downloading the file. Once the package is downloaded, go to your downloads folder and you will find the package in here. Copy it and then move it or copy it to a folder that is accessible to you. For example, don't copy to the folder that is called library or places that are protected. For example, the root of your disk. So because in a Mac you just run this Bamboo for yourself, best is that you copy it under your own personal folder. And then just double click on it and it will be extracted into a folder. Sorry, like this one. So we don't need this file anymore, and rename this to something like Bamboo. We also need another folder for the files that Bamboo will create, and we call that Bamboo Home. You don't need to use my casing. It can be all lowercase if you want. And that is it. So now we need to configure Bamboo. In order to configure Bamboo, first of all, go to your Bamboo Home and copy that path into clipboard. Then go back to your Bamboo. In Bamboo, go to a folder called Atlassian Bamboo. Then go to a folder called web-inf. Then go to classes folder and find a file that is called bamboo-init.properties. And then open it. If I open it, for me, it will be opened in Visual Studio Code, but it doesn't matter. Any editor will do. So in here, you will see that there is a folder called bamboo.home. First of all, remove this hashtag because that comments this line. Remove whatever is there and paste your home folder in here and then save this file. That's it. To start Bamboo, go to the root folder of your Bamboo installation and bring up a terminal. In the terminal, you can type ./bin. And then there is a file called startbamboo.sh. And then you run this. Make sure that it says Tomcat started. So if Tomcat is started, you can go back to a browser and navigate to http localhost 8085. Because this is the default port of Atlassian Bamboo, 8085. The first time you run Atlassian Bamboo, it asks for a license key. If you don't have a license key, you can get a 30-day evaluation license key by clicking on this link that says Generate a Bamboo Data Center License. It opens a new tab in the browser. This is where you must be logged in. If you don't have an account, no worries. Just use your email address or your Gmail or your Microsoft account or even your Apple ID to create a login, and then you will see this page. In this page, sometimes you need to have this server ID ready. If it doesn't ask for it, it's fine. If it does ask for it, just copy it from here and use it. I have created a license before. That's why you see organization test. Otherwise, if it's empty, just put any organization. It doesn't matter what you put there. Then click on generate license. This will give you a temporary license, so just copy the license key in the browser and paste it in here and continue. So the installation is completed now. I stopped this video in here because the configuration of Bamboo is basically same for every operating systems. So just jump to the lecture that is about configuring Atlassian Bamboo. Now that we have our Atlassian Bamboo set up, we can configure it. So once you have obtained your license and you put it in the license box, you get redirected to a page called Configure Instance. In the Configure Instance, you will have a name for your instance. Having a name for an instance makes sense, especially when you install Atlassian Bamboo in a high availability mode where you may have more than one instance. We will see how we can do that in a future lecture. So for example, if you have two instances of Atlassian Bamboo, you can have, for example, Atlassian Bamboo main, Atlassian Bamboo secondary, something like that. Base URL is used where an external agent, for example, a person, needs to know the address of your Atlassian Bamboo. For example, if Atlassian Bamboo sends an email to a person, for example, to a developer that your build has failed, for example, it may include a link. And that link will include this address so that somebody can click on that link and come to this instance. Again, in the future, I will show you how you can install and deploy Atlassian Bamboo in high availability mode. Just so you know, if you install Atlassian Bamboo in a high availability mode with more than one instance, this will be the address of your load balancer. We come back to it later again. Also, there are directories in here. I don't recommend that you change these directories when you install Atlassian Bamboo as a single instance, but if you want, you can change them obviously. And then you have a broker client URL. So this URL is basically the URL that remote agents will use to connect to your Atlassian Bamboo instance. I am running this on my laptop, which is a MacBook Pro, so it looks like this. But if this was a server, for example, the Ubuntu server that we used, you put the IP or you put the DNS name. If your remote agents are in the same network as your Atlassian Bamboo instance, you better use private IP or private DNS name. But if they connect to your instance via the internet, you use the public DNS or public IP. And also there is a port. This is the default port. And obviously you have to make sure that your firewall or your security group will allow traffic via this port to your instance. This number in here is the default port for remote agents. We have a discussion about the remote agents. Obviously you have to make sure that your firewall or your security groups allow traffic on this port. Then you click on continue. In the next step, you set up your database. Bamboo supports PostgreSQL, MySQL, Oracle, and Microsoft SQL Server. If you install Bamboo for your home projects or for the sake of learning, you can use a database called H2. H2 is a very simple built-in database that is shipped with Bamboo. And if you choose that, then you don't need to install any databases or JDBC drivers. But the limitation is that this is a single user database, so you should not and you must not use this for an actual scenario where you use Bamboo in your company, for example. This is only for learning and evaluation purposes. If you use something like MySQL or Oracle, you will need a JDBC driver for MySQL. JDBC driver is not shipped with Atlassian Bamboo. The driver can be found easily. If you go to Google and say connector J/J MySQL, you can find a link like this, or you just go to this address. You go to mysql.com/products/connector. You will see the list of all connectors. And then for MySQL, you need JDBC driver for MySQL. And then for Bamboo, you need JDBC driver for MySQL connector. And you can download this, which brings you to this page. You choose your operating system. I can easily just say I want platform independent. And then you can download either the zip file or the tar file. You don't need to log in. You can just say, no thanks, just to start my download, and that will start your download. So if we go to Finder, which is the equivalent of File Explorer in Windows, you will go to your download and then you will see that there is a file. You just unzip this file and that gives you a bunch of files. What you need is MySQL connector and then a version .jar. So you just copy this to clipboard. You go back to Bamboo. Inside the Bamboo installation folder, go to lib folder and paste that connector in here. Now, if we go back to our installation, you can go ahead when you choose MySQL. In this page, depending on the type of database, you will see a driver class name. Then you have a connection string. Your connection string begins with JDBC. Then the type of the driver, which is MySQL. Obviously, if you were installing on Oracle, then this would be Oracle. Then you have the IP address or DNS name, as well as the port number of your Atlassian Bamboo. This Bamboo at the end is the name of an empty database that you must have created in your database. For example, if you have installed MySQL, you must create an empty database called Bamboo in that MySQL. Also, you must create a username and password, and you must grant permission to this user on this database so it can read and write to that database. Obviously, installing MySQL is outside the scope of this subject. But if you have a MySQL or Oracle, simply you just create an empty database with a username and password, and you set the database name as well as the IP and DNS name in here. So I'm not going to continue because I'm not going to use any of these databases. I want to use the internal database because obviously this is my personal computer. I can easily use the built-in database. Then you click on next and you just wait for a couple of minutes until all the database objects are installed inside your database. After that, you have an option to import data if you already have an instance of Bamboo. For example, if you have an older version of Bamboo and you are setting up a newer version of Bamboo, you can import the data from older instance to this instance by choosing import existing data, and then you provide the Bamboo home folder address in here. Then you create an administrator account for your instance. For example, I can say my user is admin and then my password is something, and I repeat the password, and then my name is something, and I have an email. So that is it. That should finish your setup. There is one more thing that you may want to do, and that is changing the default port from 8085 to something else. When the configuration is done, you will see this page, and that means that everything works perfectly. So the last thing that, as I said, you may want to do is to change that default port. For changing default port, regardless of what sort of operating system you have, you must go to the Bamboo installation folder. Inside a folder called conf, you will see a file called server.xml, and then you open it. If you are in Linux, you use Nano. If you are in Windows, you can use like Notepad or Notepad++. In Mac, you can use like Visual Studio Code. That file looks like this. So easily search for 8085, and that brings you to this service name called Catalina. And all you need to do is to change this port. Like if your port 80 is open, just change this to port 80. Also, there is a port for accessing Atlassian Bamboo using HTTPS. You can set it in here as well. In a separate topic, I will explain how you can set up HTTPS for your Atlassian Bamboo. If you set up Atlassian Bamboo for your company and agents or users access it via the internet, you must set up HTTPS obviously. So change the ports of HTTP as well as HTTPS to whatever port that you desire, and then save this file. Obviously, to make this effective, you have to restart your Bamboo. So I am on my local computer and I have run Atlassian Bamboo using startbamboo.sh. There is also a file called stopbamboo.sh. 99% of times it fails. So instead of calling it and seeing an error message like this, you can simply, if you run it on your local machine, you can simply close this terminal window, or in Windows, just close the command prompt window, open it again, and then just run the startbamboo.sh again. If you have set up Bamboo as a service in Linux, you just simply say system control stop service, Bamboo service, and then again system control start service, Bamboo service. So our installation and configuration of Atlassian Bamboo is completed now. If you want to set up Atlassian Bamboo in high availability mode or with HTTPS access, you can watch the relevant topics as well. If you are only installing it for the learning of Bamboo, obviously it's enough for now. You can continue adding build agents and start building your code. In this section of the course, we want to learn about the build agents. So when we install Bamboo, we are installing the Bamboo server, not the Bamboo build agents. Bamboo server doesn't have capability of building or compiling or testing your code. It only maintains the list of your projects and the configuration of project. For example, all the steps that we need to take in order to package and deploy a code as a software. In this diagram at the left, you see the Bamboo server software. It's not necessarily a physical server, it's just a Bamboo software. In order to prepare a code and deploy it as a software or an application, we need Bamboo agent software to be installed as well. When a user logs into Bamboo and says, I want to build this project, the information and configuration of that project gets pushed to the Bamboo agent software. The project information, as I said, includes all the information regarding the steps we need to take to compile, package, and deploy the application. Then your source code is probably somewhere like in GitHub or Bitbucket, and the Bamboo agent software has already received the information about how to log into that GitHub or Bitbucket and where your repository is. So it's able to fetch the code from your source control, in our case GitHub, and then performs the build if it needs building. For example, if we are working with a Java source code, and then if we want, we can also run the unit test and we can package it and deploy it somewhere, for example, on an application server. So up to now, we have managed to install Bamboo server, but we haven't installed a Bamboo agent software. So in the upcoming lectures, we will see that how we can deploy the Bamboo agent software. Before that, I just will have to explain the types of Bamboo agent software that we have. Now that we know what a build agent is, let's see what type of build agents are available to us. There are two main types of build agents. The first one is a local build agent, and the second one is a remote build agent. Local build agent comes with the Bamboo software. So when you install the Bamboo software, automatically a local build agent is deployed with it. You can use the local build agent for the purpose of development and testing, or if you have a home project, you can also use the local build agent for your home project. It's not suitable to be used by multiple users across multiple projects. The second one, as I said, is the remote build agent. A remote build agent can be used for all purposes. You can use it for your testing and development as well as for production. These agents are called remote because they are deployed to or they reside on a server or computer other than the server or computer of your Bamboo server. So you never install a remote agent on the same server or virtual machine that hosts your Bamboo software. One big benefit of having remote build agents is that you can have several remote build agents for a single Bamboo software, and this enables us to distribute the workload of building the different software and projects across multiple servers. It also enables the build and deploy of various technologies. For example, if in your company some teams use Java and you also have some .NET projects and you have decided at some point to switch to Python, you can create a build agent server specifically for compiling, testing, and deploying Java, .NET, and Python separately. You don't need to mix them on one single server. And as you as an experienced developer already know, after a while a build server gets trashed a bit. You will install so many different libraries and at some point you want to basically start fresh. So having a remote build agent enables you to destroy or kill the build agent server and then just create a new one from scratch and use that as a fresh build agent. A local build agent, as I said, is within the Bamboo server. A remote build agent, however, is outside the Bamboo server. And as I said, you can have a Bamboo agent for compiling and deploying Java applications, another one for packaging and deploying Python applications, and another one for example, .NET applications. You can have virtually unlimited build agents. However, your number of build agents is limited by the license agreement that you purchase for your Bamboo servers. So you always have to refer to your license that you have purchased and see that how many build agents you can have. Before we get into installing the build agents, I want to introduce you to a very specific type of build agent called Elastic Build Agent. Elastic Build Agents are only available in Amazon Web Services or AWS. So if you don't deploy your build agents to Amazon Web Services, you can skip this lesson completely. So we said that we have local build agents and remote build agents. Remote build agents can have two types. One is static and one is elastic. The static remote agents are always available. So if you have a project in Bamboo and you click on the build button, the static build agent is running already. It can immediately pull the source from the source code and compile it or package it. Elastic build agents, however, are not always available. You give the definition of the elastic build agents to Bamboo, but then Bamboo doesn't really create the build agent. It waits until you want to build the project. So if you click on the build and no build agent is available, Bamboo sends instructions to Amazon Web Services and says, I need a build agent. And then Amazon Web Services will create an instance for you, and then Bamboo can use that to build the code or to just package and deploy the code. So let's have a quick look at the properties of Elastic Build Agent. As I said before, Elastic Build Agents are only available in Amazon Web Services or AWS. You cannot have them on Azure or Google Cloud Platform. Elastic Build Agents are based on EC2, and Build Agent EC2 instances are based on a pre-made Amazon machine image or AMI that you have to create and give it to Bamboo. Every time you want to build a project, EC2 is instantiated, and then once it's done, it will be terminated. So if you don't use the Elastic Build Agent, for example, say for 60 minutes or something like that, it will be terminated automatically. Let's have a look at pros and cons or advantages and disadvantages of Elastic Build Agents. One benefit is that it's suitable for companies or teams that need many build agents. So if you work for a large company that has many teams and many projects, then you may need many build agents. And if you create one build agent, for example, per project, you may end up with so many build agents, and that is going to cost money for your company. So if you don't want to always have, say, 20, 30 build agents running, you may consider Elastic Build Agents. And as I said, it can be a good strategy for cost saving. If cost saving is a priority for you, for example, if your budget is small, then you may want again to consider Elastic Build Agents. One disadvantage of Elastic Build Agents is that agents may take several minutes to become ready. Especially if your EC2 instance is based on Windows, it may take like 10 minutes to become available. And this may be frustrating to your developers, testers, or people who deploy the code. I once used Elastic Build Agents for a small team, and to be honest, the team didn't like it much because, as I said, they would have to always wait for the build agent to become available, but that was done because of the cost-saving purposes. Another disadvantage is that if you want to update your build agent, for example, you want to install a new tool on it, or you want to upgrade the version of your compiler, for example, you want to upgrade the version of your Python, you cannot do that directly on the agent because the agent will be destroyed after a few minutes and you lose all your updates. So you have to get your DevOps engineer, or you have to do it yourself. You have to basically update your AMI and then introduce it back to Bamboo and then allow Bamboo to spin up new build agents. This may take a lot of time. Let's learn about the basics of deploying a build agent. So in order to deploy a build agent, you must access your Bamboo software. So if you want to install the build agent on your local machine, you go to localhost.8085 or whatever port you have set. You bring up Bamboo in a browser. If you want to do this on a remote machine, in your remote machine, you also have to be able to access the Bamboo software. Because of that, I highly recommend that you assign an IP address that never changes, or even better, a DNS name to your Bamboo server machine. And then your Bamboo agent server will be able to access that Bamboo server via the DNS name or the IP, and you can do that via either a browser, for example Google Chrome or Microsoft Edge, or if your Bamboo agent server is like Ubuntu or something like that and you don't have a browser, just use curl or wget to download the agent software. Then you just run the commands that Bamboo give to you to install the agent. So let's go back to Bamboo. So in Bamboo, because I don't have any agents, as soon as I go to home page, it says install remote agent. Alternatively, I can click on this cogwheel on right side of the screen, top right, click on agents, and then I can work with agents here. There are two buttons. One is add local agent, which allows me to add a local agent, and also install remote agent, which allows me to install a remote agent. So if you are installing a remote agent, you have to bring up this page on the build agent server, not the Bamboo server itself. It's easy if you use Windows, you can have just a browser like Chrome and then access your build agent via the IP or DNS and log into it and then come to this screen. Or if you have, say, Ubuntu or Linux that doesn't have a browser, then you do it in a different way that I will show you very soon. So regardless of that, either you have a local build agent, you click on it, or you install a remote build agent. So the process of installing a remote build agent is equal across all operating systems. It doesn't matter what operating system you use as long as you have Java installed. So the first requirement for installing the Bamboo build agent is that you must have Java installed on your machine. At some point, I explained that how you can deploy JDK. Use that and deploy JDK on the build agent machine. Then, if you are using a browser, click on download remote agent and then just copy paste this and run it either in terminal or in command prompt. If you don't use a browser, you just right click on this button and say that copy the link address. Then you can use curl or wget to download that package from that address and then run this command. We will see this in the upcoming lectures. It's quite easy. So let's go and install a build agent. Now that we have learned about different types of build agents, let's set up a local build agent so that you can use it for practicing. As you already know, we hover the mouse over this cogwheel on the top right corner of the screen and then we click on agents. Then we click on add local agent. And once you have done that, you need to provide a name for your local build agent. I can simply call it local agent or local build agent and click on add. When you click on add, the build agent is set up on your machine or wherever you have deployed the Bamboo to, and then you will see some information. Right now we are on a tab called capabilities. So that is the default tab. As you can see here, it says capabilities. So a capability for a build agent is any tool or software that allows you to compile, test, or package your code and turn it to a deployable software. So by default, it tries and finds what I have on this machine or on whatever server you have used to deploy Bamboo on. So on my machine, I have Maven and it has discovered it, and I have Node.js. I also obviously installed JDK so I could install Bamboo, and it has discovered my different versions of JDK. Also, it has discovered my Git and my Docker. So some of those are discovered, although I have other things that it didn't manage to discover, but no worries, we can install those. So if you need anything, for example, you need Python or you need .NET and you don't see it in this list, you can easily add them by clicking on add a capability link at the right side of the screen. So some of these capabilities are known. For example, if you want to show where your JDK is, you just click on JDK and then you provide your Java home path. You can also install and introduce any of these like Git, Docker, you saw them that I already had them, and Kubernetes, which points to the executable of kubectl. Unfortunately, this list is very short because Atlassian hasn't updated this list for years. So it's a bit old, that's why it's quite short, but that's not a problem because you can install executables as well. Again, when you click on executable, that also gives some options because again, it knows some of the executables. For example, if you build .NET application using MS Build, you click on MS Build and then you provide the path to the executable file of MS Build. This is for .NET developers. Or you can do the same thing with Node.js or NUnit for running unit tests, PHP unit, different things. If you have an executable that you don't see on this list, you simply click on command and then you provide a label. For example, I can call this .NET and then you provide a path to the executable. For example, I have .NET SDK installed and it's got an executable. If you use Windows, it will be like .NET.exe. It will have an extension. In Mac, which I am using, there is no extension, so it's just .NET. So what we do is that you can copy the path and then copy it in here. And then you just click on add. So now you have a capability called .NET. Also imagine that I run AWS commands. For example, you need AWS CLI in the command line of AWS, Amazon Web Services, to deploy your software into AWS. For that, you just find the executable file, in my case, AWS CLI, and then you just copy the path into clipboard, and then you go back. You click on add capability, and we say we want to add executable. That's a command. Label will be like AWS CLI, and then just paste it here. This is not just a path, it has to include the name of executable. For example, as I said, in Windows, that would be aws.exe. So this is not the path, this is the executable file name. And then you click on add. You can keep adding capabilities. And then when we talk about projects and how we actually build the projects, you will see that we can do different things with capabilities. By these capabilities, Atlassian Bamboo will identify if a build agent is suitable for your type of project. So it's important to have all the capabilities that you need in order to compile and test and package your applications. There are other tabs here as well. So if we go one level up, you can delete this build agent by clicking on delete. You can disable it. So if I click on disable, it will become disabled, and then I can enable it again. And you can stop it if it's building something. We will dig into the build agents later. So now I'll let you install your local build agent, and then in the next lecture, we will deploy a remote build agent. Now that we know how to set up a local build agent, it's time to learn how we set up a remote build agent. We call them remote build agent because the server that hosts the build agent is different to the server that is running the Bamboo as the Bamboo application. What you see here is the console of Amazon Web Services. If you are not familiar with Amazon Web Services, it's all good. All I'm doing here is basically the basic networking. You can always repeat the same things in other environments. For example, if you work in Azure, you can repeat the same thing in Azure or in Google Cloud Platform or anything else. What you see on this screen are two virtual machines. The first one is a virtual machine. I call it Bamboo server, that is running the Bamboo application or Bamboo server. The other one is a Windows machine where I'm going to set up a remote agent. It's a Windows machine, but it doesn't really matter because the procedure of setting up a remote agent is identical across all operating systems. As long as you have set up JDK on that machine, you basically run the same procedure. Things you need to have in mind is that in your Bamboo server, you need to open 2 ports. In your Bamboo agent, you don't need to open any ports because always the agent connects to the Bamboo server. Bamboo server never makes any network connections, for example, TCP connections to the remote agents. It's always the agent that connects to the Bamboo server. So in your firewall setting, for example, because I'm in Amazon Web Services, we call it security groups. You need to open 2 ports. First of all, you need to open the port of your Bamboo server. I'm using the default port, which is 8085. So I have allowed TCP traffic to port 8085. Also, you need to open a port that is used by the agent to connect to Bamboo server, and that is 54663. You need to open these 2 ports. Allow incoming traffic on these 2 ports. That's one thing. Also, as long as your 2 machines or virtual machines are in the same network, your build agent machine, for example, this one, should be able to connect to your Bamboo server, which is this one, using the private IP. But if you want to make it even nicer and make sure that if your IP changes for whatever reason, still the agents can find the Bamboo server, you can create a domain name. So either you just go to GoDaddy or some other websites and buy a very cheap domain and assign it to this public IP. If you have a public IP, if there is no public IP, or if you never want to connect to your Bamboo server machine from your local machine, and it's only for the agent to connect to your Bamboo server, either use the private IP or create a private DNS name. So in your networking environment, in my case, Amazon Web Services, there are always DNS services. In Amazon Web Services, it is called Route 53. So when you go to Route 53, you will have a list of hosted zones, which is basically your DNS names. So you don't need to create like a .com or any other proper domain names. You can create a private hosted zone. Mine is called bamboo.local. And then whether you do your DNS in here or in godaddy.com or any other places, you will create an alias, which is a entry, and then you just code it like server.bamboo.local or any other name. And then because again, these two machines are in the same network, the agent should be able to use this DNS name to find your Bamboo server or this one at the top. So the last thing is that if you use Windows, if you have set up your Bamboo server on a Windows machine, although you have already allowed traffic on port 8085 and this 54663, still traffic might be blocked by Windows firewall. So you go to your Windows. This machine that has the default background is Windows Server for Bamboo server. This one that has a fancier desktop is the machine. It's a Windows machine where I'm going to install the Bamboo agent. So when you use Windows, either completely disable the firewall because double firewall doesn't really add any value, or go to Windows Firewall and add 2 more rules. If you want to not disable the Windows Firewall and add rules, open up the Windows Defender Firewall, go to Inbound Rules, create new rule, port, and then say I want to open port 8085 or any other port that you use to connect to Bamboo server. Then give it a name, for example, 8085. Also repeat this with another port, which is 54663. Again, I say 54663, or you can name it in a different way. So just make sure that these 2 ports will accept traffic, or as I said, completely disable the firewall. That's it. Then to install the agent, you will log in remotely to the machine where you want to deploy your agent. You need a browser. If you don't have a browser, for example, if you are deploying to Ubuntu, on your machine, connect to your Bamboo server. For example, go to localhost 8085 or the public IP, then 8085. So for us, that would be server.bamboo.local on 8085. Then I log in. And then I need an agent. So right now I'm on a Windows machine where I'm going to install the Bamboo agent. If you, as I said, use Ubuntu, do this on the machine where you have set up Bamboo server, or connect from your local machine to Bamboo server. Then right click and copy the address of this download button. So you can say copy link address. You only need the link that this button is pointing at. And then if you are in Ubuntu, you can use curl or wget to download it. If you are in Windows and you have, for example, Microsoft Edge or Google Chrome, you just download the remote agent jar file. And then you just open this folder. So I downloaded my package into download folder. So you need the address. Open a command prompt as an administrator. Then copy this command that is given to you to clipboard. When we want to use this command, if you want to use DNS name, just change this IP to DNS name. So first of all, you have to be where your jar file is. So in our case, that was in downloads. So it's here. You have to run this command where your jar file is. So I will paste it here, and then I just change this IP to our DNS name, which was server.bamboo.local. If you are in a Linux machine, just run it as it is. If you are in Windows, add a space at the bottom and add install NT service. This will run your agent as a Windows service. Done. Now, if we go to services, you can see a new service. In Linux, you can just see a service like with system control and list the service. You will find a service that is called Bamboo Remote Agent and start it. Again, if you are in Linux, you can use system control, start Bamboo Remote Agent. In Windows, you right click and just say start. If you have done your networking correct, then when you go to your Bamboo machine or remotely connect to your Bamboo service, for example, let's go to machine where we have installed Bamboo and go to localhost 8085. We log in. So if we go to this cogwheel and then choose agents, you will see under remote agents, under agent authentication, there is an agent and it's waiting for us to approve it. And this is a security feature because anybody can basically try to install an agent and connect it to our service. And that agent might be just a bot that tries to hack our service. So to make sure that we only allow agents that we know, we need to approve the access. So you just click on approve access link and then the access is approved. That doesn't mean that immediately you will have an online agent. It's going to take about 2 minutes for the agent to be loaded and be available. While the agent is connecting and loading, you will see some logs in here that shows you what's going on. It's not really that clean and visible. I normally just wait for a couple of minutes until I see an agent here that is up and running and alive. Okay. After a minute or so, you will see that one agent is here. It's idle. Idle means it's not building or compiling or packaging anything. If you click on the agent, similar to a local agent, you will see the capabilities. So MSBuild is installed by my Windows. That's why it's there. And also I installed JDK, but it doesn't have any other capabilities. Similar to a local agent, if you want more capabilities, you just add a new capability. For example, set up Python or Java or .NET SDK on build agent service, not on the Bamboo server, and then either on the Bamboo server or on the Bamboo agent machine, introduce the path. Make sure that you won't make a mistake and install the SDK on your Bamboo server. So I said that the machine that has the standard Windows background is the Bamboo server. You don't need to install SDK on this. You have to go to the machine that you created for Bamboo agent. In our case, this one with a fancier background. Set up your SDK here. For example, download and set up Node.js or Python or Java or .NET, whatever in here. Grab the path of your executables and then go back to your server and add the capabilities, or you can even do it in here. So if you are on Bamboo logged in as an administrator, you can still go to agents and open the agents. It's just basically as normal that you do administration, click on add capability, and then you can say, I have installed, for example, Docker or Git or JDK, or it's just an executable I'm introducing, which is, for example, Maven or MSBuild, or it's just a command. For example, for .NET, you need a command and then path of that command executable. For example, your .NET exe or your PHP or your Python. For this course, I have created some small sample applications in different languages and I have put them on GitHub. I will link them to the relevant topics and then we will basically work with those. As we work with those sample codes, then I will set up capabilities that we need. Up to here, what we have learned is that how we can set up a remote build agent. In this topic, we want to learn about projects and their structure in Bamboo. In order to compile and deploy your code, you must create a project. Every project may have one or more than one build plans. Based on my experience, every project normally has one build plan. Then every build plan has one or more than one stages. When you create a build plan, Bamboo automatically creates a stage for you. Stages are executed sequentially, which means that stage B has to wait for stage A to complete its job in order to begin working, and stage C only starts working once stage B has finished its job. Within every stage, we may have one or more jobs. Jobs run in parallel. So job B doesn't have to wait for job A to complete. They work simultaneously. And every job has one or more than one tasks. Tasks also execute sequentially. So task B has to wait for task A to complete in order to start working. So in this example, stage A has two jobs. The first job in stage A has two tasks, and the second job has one task. Under stage B, there is only one job with three tasks. And then stage C has one job with two tasks. Now let's see this structure in an example. Imagine that you work for a company where you have multiple clients, and in Bamboo you create one project per client. For example, a project that is called Client Company X. And then you have sold software to each of these clients and you customize the software. For example, for customization that you make on the accounting software for Client Company X, you have created a build plan called Accounting Plan. Obviously, you need to have stages under each plan. So you have 3 stages, for example, for Accounting Plan. They are called Get Code, Build Code, and Publish. And as you already know, they will execute sequentially, one after the other. Then under Get Code, you have a job called Git Checkout. And it has 2 tasks. First is a Git pull. The second one is a Git tag branch. So as you know, if you want to get the code from Git, you run git pull command, and then optionally you can tag your branch to show that this branch has been checked out or something like that. So you can run 2 git commands one after the other under the job that is called git checkout. Once you have the code, you can build your code. I have imagined that accounting software is a .NET software, but it doesn't matter. You can imagine it's Python or Java or whatever. Normally, you have libraries for every code that you download. Because I have imagined this is a .NET application, I have said restore NuGet packages. If you have used Python, you can imagine pip restore the packages. Or if you use Java, Maven get the packages. Whatever technology you use, normally you need to download your libraries from the internet. Then you build the code. Especially if you use Java or .NET, you need to compile your code. And also, once your code is compiled, you can run the unit tests. Once the code is built and unit tests have passed successfully, you can publish the code. For that, you create a job called Publish under the stage called Publish. And what it does is that first it runs a task that zips the output into a zip file. And then the second task copies it to somewhere. In here, I have imagined that we copy our zip file to Amazon S3. Now let's go to Bamboo and create a structure for a sample code that I have on GitHub. So far, we have learned that we can connect our Bamboo to any given GitHub repository, either with using a public GitHub repository or using a username and password. Before we go ahead and learn about more ways of authenticating with a generic Git, I want to show you an easy way for authenticating your Bamboo against GitHub, because most teams and companies these days use GitHub. So let's do that first. So I'm going to delete the repository that we created and do it again. So imagine that I want to connect to GitHub and clone or pull this repository that I have created for this course. Again, I just need the clone path, that is HTTPS, and we go and create a new repository. This time I want to say that I'm going to use GitHub. Some large companies use GitHub Enterprise, and this method is specifically useful for GitHub Enterprise. So you provide a name, for example, the sample app that we used before, we can still use that. If you are creating this repository for yourself, you can say that only you have access to this repository. But if you are an admin and you create this repository for everybody in your company, you can choose to say all users have access to this repository. Then you need your username. If your GitHub account is personal. You put your own username, otherwise you will create a user. For example, if you are the admin of a GitHub enterprise, you put a username in here. For example, this is my username. Then you need to create an access key. For that, click on your own picture on the top right side of the screen and then go to settings. In the settings, at the left, there is a developer settings. This is where you can create a personal access token. So the classic access token gives access to your entire account, but a fine-grained token gives access to a specific repository. It's very fine-grained. You can create any of these. It's up to you. It doesn't matter. Both will work. So let's say that I want to create a classic token. We provide a name. For example, I can call this Bamboo token. Then specify an expiration length of time. For example, you can say this token is only valid for 7 days. By default is 30 days. Also 60 days, 90 days, or any days that you provide, or no expiration means that this token is forever. It is not a good practice in terms of security, so it's highly recommended that you limit it to, for example, 60 to 90 days, and then just remember to refresh this token, both in GitHub and in Bamboo. Then you provide the access details. If you just want to use this to pull the repository, only choose repo. You are not going to write anything back to GitHub, so just repo is fine, and then generate the token. This is the token that you need to put in Bamboo. So you just copy that and then go to personal access token and paste it in here. If I click on load repositories, then all my repositories will come up here, and then I can say I want Bamboo v2 sample1, and the branch was main. Test connection will obviously pass because we have already loaded the repositories, and then we click on save. So this was another way for connecting to your repository, but your repository must be on GitHub, and that is the approach. In the next lecture, I will show you that how you can do this using the SSH keys. That is a generic way. It works both on GitHub and on a generic Git repository. To create a project for compiling and deploying our source code, we need to pull the source code from the source control system, such as GitHub. If you don't already have a source code somewhere such as GitHub or Bitbucket, you can go to my account in GitHub. I will attach the link of my account in GitHub to this course, to several topics of this course. You can go here and then you will see that I have a ton of repositories. You can pick up any of these for practicing. For this topic and the next few topics, I have created a repository for you. You can use this one if you want. So we just want to compile and package this, so you don't really need to know what it does. For now, just imagine that you have a source code on GitHub and you want to pull it. There are different ways for pulling the source code from the source control system, and in this section of the course, I want to show you a few of those ways, and hopefully that will show you the path for different repository systems such as Subversion and Bitbucket as well. The first thing that you need is to connect your Bamboo instance to your source control system, in our case to GitHub. You can do this at the Bamboo level or at the project plan level. The procedure is identical, so I will show you how you do it at the Bamboo level first. So if you want to create a repository in Bamboo that basically maps to a repository in your source control system, you can go to this cogwheel on the top right side of the screen and click on linked repositories. In here, we link Bamboo to the source control system. We click on add repository, and as you see, there are several options here such as Bitbucket Cloud, GitHub repository, Bitbucket server, Subversion, which is a bit older, and Git. Git is basically just generic Git. You are not working specifically with like GitHub version of Git or Bitbucket version of Git. So if you want to pull a public repository like this, the easiest way is just to use Git. So you copy the path, HTTPS path of your Git repository, and then you choose Git. Git is generic, it works for any Git repository. And you provide a name. For example, I can say this is a sample app 1. And then you put the repository URL in here. If the repository is a public repository, then you don't need any sort of authentication. And for the branch, you put the branch name. So the default branch in GitHub is called main. So you can just type in main here, and that will pull the main branch, and you can test your connection. So that was the simplest way of connecting our Bamboo instance to a source code repository. Now, if this repository in GitHub wasn't public, you would need to log into GitHub. For that, the simplest way of authentication is using a username and a password. So I have an account in GitHub, as you can see. So obviously I have a username and a password. You can use that username and password and then save it in here to clone the repository. But there are two limitations, basically one limitation and one security problem. The security problem is obviously the fact that I'm putting my admin username and password that belongs to GitHub to another system, not the best practice. And also, if you enable multi-factor authentication in your account, for example, in my case, password and authentication, you will see that I have enabled two-factor authentication, which means that if I try to log into my GitHub account, it will send me an SMS message and I need to put it back in a screen on GitHub. Otherwise, I won't be able to log in. Obviously, your Bamboo isn't able to do that. So if you have enabled two-factor authentication in GitHub, you won't be able to use username and password, and you need something else, which is the SSH keys, which we will see in a different topic. So right now, what we managed to do was to connect our Bamboo instance to a GitHub repository, but that repository is public, or it's not public, but it has username and password without two-factor authentication. In the next lecture, I will show you a different way of connecting your Bamboo to GitHub. In the previous lecture, we managed to connect to GitHub using a token that was generated by GitHub. That method is perfectly fine as long as your code is on github.com. But if you use a different source control system such as Atlassian Bitbucket, or you just want to connect to your Git source control system using a generic Git connection, then you have another option, which is the using of SSH keys. SSH keys are basically a pair of public and private keys. You upload the public key to GitHub or Bitbucket or wherever your Git server is. Then you upload the private key part to your Bamboo, and then using the private public key pairs, these two systems can talk to each other. To create SSH keys, you need a tool called SSH Keygen. If you use Mac or Linux, you have SSH Keygen already. So if I just type SSH Keygen, you will see that it creates a default key for me. If you use Windows, you won't have SSH Keygen, but you can install it very easily. So in Windows, there is a system called WSL, and in any Windows, as long as your Windows is Windows 10 and above, if you type in WSL-install, the Linux command tools will be installed on your Windows, and then you will have access to SSH Keygen. In that case, when you go to command prompt, then you can type in SSH-Keygen and make sure that you use the -O switch. So -O tells SSH Keygen to create a key that is compatible with OpenSSH standard. It's a more secure key compared to the legacy keys that would be created by SSH Keygen, and also GitHub expects the OpenSSH version of the keys. Then -T switch is for the algorithm. I use RSA algorithm because it's accepted by almost all source control systems. And -B is basically how many bits you use for encryption. So I use 4096. Then use the -F switch for specifying the output file and location. So because I'm using Mac, I use /. If you use Windows, obviously you use \. Then provide a name without any extensions. And obviously, if you want to provide a directory or folder name as well, you can do that. So I call this something like Bamboo Git and no extension. Then you can optionally provide passphrase, which is basically a password. I just ignore it. Then your keys should be generated. So if I do a list, you will see that I have two keys now. One is Bamboo Git, one is Bamboo Git Pub. The one with the .pub extension is the public key. The other one is the private key. That's why we didn't provide an extension, so that extension will be created automatically. Now we need to go back to GitHub and then provide the public key. So for that, first read the public key. You can read the public key with Notepad in Windows. In Linux, you can use Nano or any other text editor. On Mac, I can either use Nano or Visual Studio Code. For example, this is my Visual Studio Code, and I can open Bamboo here. So just copy it to clipboard. Then we head to GitHub. This is my GitHub. In GitHub, there is an SSH and GPG keys section. There is a similar section in Bitbucket as well. Then we click on new SSH key. We provide a name, for example, Bamboo connection, something like this. And your key type is authentication key. Then you paste the key content in here and add SSH key. So we are done in GitHub for now. We head back to Bamboo. In Bamboo, you can create credentials and allow other people and other teams use it for their projects and build plans. For that, again, click on this settings icon, the cogwheel icon on the top right side of the screen, and click on overview. That shows you the administration page. Obviously, you must have the administration privileges in Bamboo. Then at the left, you see shared credentials. You can create different types of credentials. For example, if you want to connect to your source control system using a username password that you have created, but you don't want everybody in your company have that username password, you just want them to connect and use it, you can put it in here as a username and password credential. Right now, we want to create an SSH key credential. So we click on SSH key. Then provide a name. For example, I can call this GitHub. Then you need the private key part. So again, we head back to an editor, in my case, code. We open the public key, copy it as it is, do not make any changes. And then, because I didn't provide a passphrase, I can just delete it and then save. Now you can use this credential to connect to. So let's click on linked repositories. We have done this before and we want to create a new repository. So I click on add repository button to create a new repository, and I want to connect to GitHub using the generic Git. So we provide a name, for example, sample app. We used this before. And then I need the repository URL. So for repository URL, you go back to your repository in GitHub or Bitbucket. If you remember, so far we use the HTTPS link to our repository, but you cannot use HTTPS with SSH keys. You need a specific clone path for SSH. So we copy that back to Bamboo and then we put it in here. Then your authentication type will be SSH key, and your key will be here. If you don't want to use any of the stored keys, you just say, I want to use a custom SSH key. Then you upload your private key in here. But it's highly recommended that admins maintain all the credentials and you just use them. Then for the branch, we use the main branch and then test connection. Connection was successful. So this is one way of connecting to Git source control systems. If you don't have your source code in GitHub and you don't want to use the token, you can use SSH keys instead. Now let's go and create a project in Bamboo. Now that we have connected to our source code in GitHub, let's create a project. So if you have no project and no build plan, on the dashboard you will see a button that says create your first build plan. Alternatively, you can create a project by clicking on projects at the top of the screen. And then you click on create project. Then you provide a name for your project. So our repository was called Bamboo sample app. I can type sample app in here. You can provide a description as well. Also, every project needs a unique project key. It's generated automatically, but you have a chance to change it here. However, once you save your project, the project key cannot be changed. Also, when you create a project, that is only visible to you. If you want other users to see this project, you click on allow users to view this project. And then we click on save. As I said before, under every project, there is a build plan. So there is a create plan button. We click on it and then we create a plan. So the project is a sample app that we just created, and then we provide a name for the plan. We can call this sample app. You can also give any other name. Also, a plan key is created for you, which again has to be unique. And once you create the plan, you cannot change the plan. Similar to a project, if you click on this checkbox, which is for allow all users to view this plan, the plan will be visible to all other users under that project that this plan belongs to. So we click on create. Right here, you can attach your plan to a source control system that we created before, or you can just say there is no repository. You can select none if you want to attach your plan to a source control repository later, or if for any reason you don't have a source control, you just want to do something that doesn't need any source control checkout or connection. So for now, we want to connect to an existing source control, and if you remember, we created a global repository before, and that was called sample app 1. We can just select that, and then we save and continue. In the next step, click on create so that we can work with this project in a normal menu. So again, if I click on projects, what we have here is a project called sample app. If I click on it, there is a build plan inside it called sample app again. And if you click on it, then you will see that when you executed this build and all the stats related to this build and things like that. If you want to add stages, tasks, jobs, and things like that, you need to go inside the plan and then go to actions menu and then click on configure plan. By default, you will be on the stages tab where you see that there is a default stage, and inside that default stage, there is a default job. For the default stage, there is a cogwheel button where you can change the configuration of this stage or just completely delete it. If I click on configure stage, you will see that I can change the name of this stage. For example, I can call this compile and test, something like this. And then inside it, there is as you remember, every stage will have its own working directory, and every job will also have its own working directory. So if you check out your code in one stage, it won't be accessible in the other stages. You will have to check the code out again. And same applies to the jobs. If you want to create a job with a different name, you can delete this default job and just create a new job by clicking on add job. So I want to create a new job, and we provide a name for the job. This job that I'm going to create is for compile the code. Similar to projects and plans, jobs also have a unique key, and we just click on create job. Before clicking on create job, you will see that it says run this job on the agent environment or in a Docker container. I will show you how you can run your job inside the Docker container later in a separate section. By default, all the jobs are executed in the agents server, and they use the agents files, programs, tools, and environment variables. So they share the environment with the agent. So I click on create job, and now we have a job called compile code. If we click on the job, you can see that we can add tasks. Every time you create a job, one task is added automatically, and that is for the source control checkout. So automatically it checks out the source code that you have chosen and attached to this task. You can add more tasks by clicking on add a task button, and there are many tasks that you can choose from. If you want to do more with your source control system, you can click on source control, and then you can branch a repository, create a new commit, push repository, or repository tag. I highly recommend that you always tag your repositories when you build a source code, because that will be a good way to mapping your build to a revision in your source control. For now, I click on repository tag, and I just provide a task description, tag repository, and there is a tag name. You can provide a tag name. As long as this tag name doesn't already exist in your source control as a tag on that given repository, you can provide any name. So it can be like even hello. But if you do this hello twice, your build will fail because you cannot reapply a tag twice. So for that, leave whatever you see in the tag name. When we learn about variables, we come back to this and we will see what this exactly means. So for now, just click on save. So when this job runs, it does two things. It checks out the code and tags your repository. So for now, if we want to see what happened, if we go to project level, for example, you will see that there is a run button in front of the project name, which means that it will run all the plans under that project. If you have more than one plan, right now we only have one build plan. Or if you go inside the project and you will see the plan, you can run your plan individually by clicking on run and then say run. When you run your build, you will see that logs are pushed on the screen. And if you see this green bar at the top, your build is successful. For now, if I go back to the repository that we had in GitHub and I go to releases section, it says there are two tags and this tag at the bottom was created by Bamboo. You don't have to tag your repository or your last revision in the repository. It's just a good practice to do that. In the next lecture, we will compile our code and we will create an artifact. Now we want to compile and build our code. Obviously, this doesn't apply on all programming languages. For example, if you use Python, you don't compile the Python script, but still you need to download the libraries. And also at the end, we need to create an artifact. So let's do that. As you know, we want to work on this repository that is called Bamboo v2 sample app1. The code is written in .NET, but again, it's irrelevant. If you want to use some other code, for example, in Python or Java, you can by all means use your own code. My sample project has two projects inside it. So one of them is called Search API. Again, don't worry about what it actually does. And also it's got another folder, which is called Search API.tests, which includes the unit tests. I have cloned this repository, as you see in this folder on my local machine. It's got two projects or folders, Search API, Search API.test. Also, let me show you something else. What you see here is inside the Bamboo-home folder. And as you can see, a new folder was added the first time we ran our build plan in Bamboo, and it's called local working directory. Once you run your Bamboo plan, it will create a plan under the unique keys of the job, the stage, and the plan. And if we go inside it, you see exactly the same files and folders as the one on my local machine. And that is because we had a task to check out the source on the agent. Right now, I'm using a local agent, which uses my local machine. So you see these files that are checked out or cloned by the stage in Bamboo, by the source control task in Bamboo, and also these are the ones that I cloned manually. And I mentioned this because I want to mention that it's a good practice to clone the code on your local machine first and then try to compile it and build it successfully, then use the same commands inside Bamboo. So let's see how we do this. What you see here is files on my local machine. There are two folders called Search API and then Search API.test. The first command we want to use is for restoring the packages or libraries. For that, there is a command called .NET. If you remember, we added .NET as a capability to our local build agent, and then restore downloads the libraries. And we want to do that for Search API and then Search API.csproj. If you don't use .NET, csproj is the extension of a project file. So I press enter key and then we will see that the packages are downloaded. So we can use the same command in Bamboo. So .NET is a capability that we have added already. All we need is basically this parameter. So let's go back to Bamboo. We can add a new task. For the task, if you want to compile and build your source code, click on the Builder tab and you will see that there are so many built-in compiler wrappers already. For example, if you wanted to use Xcode, Visual Studio, MS Build, if you want to build your .NET application with MS Build, you can use this. There is Maven. There are all sorts of builder wrappers in here. If you use something like .NET Core or like in this list, I don't see Python, you can use a command. This is a generic command. The task description will be restore packages, or you can say download packages. Executable is .NET. If you remember, this was pointing to the .NET executable. And then for argument, just put that restore and then project name. And then you just click on save. Now let's go and work on compiling this. For the compilation, we do basically the same project using build. Instead of restore, we say build. When you use build command, you have to provide an output folder. You can just say once everything is compiled, put it in a folder called output. Let me copy this into clipboard first, and then we run this. So as you can see, it starts compiling, the 0 error. Now if I do a list, you will see there is a new folder called output. That is where all the compiled files reside. So we go back to Bamboo and add a new task. And we say we want a builder again, and then command, and then this time we call this build or compile. And we use .NET executable. Argument was build, and then output folder, save. So now let's run this again. So we see the green bar, that means the build was successful. Now let's go to Bamboo home folder, and then under local working directory, we open the working folder, and you see the output folder in here. It includes all the files that are generated as a result of compiling the code. So the next step would be creating an artifact. We create an artifact first, then in a separate section, we will work on running the unit test. In order to create an artifact, you have to go to your plan and then go to configure plan. Artifacts are created at the job level. So when you go to the details of your plan, go to your stages and then click on the job, and then you will see the list of tasks, obviously, but also almost next to the tasks tab, there is an artifact tab. So at the end of running multiple steps sequentially, you can create an artifact. For that, as I said, be on the artifacts tab and then click on create artifact and provide a name for it. For example, we call this search API. And then you provide the location. The location is basically where all the compiled files are. And if you remember, we put them under a folder called output. So we type output. Copy pattern means what files do you want to pick? We want to pick all files, and star means every file. Then click on create. Now I run this again. So again, we see this green bar. Now if I click on artifacts, you will see that there is one artifact here. We don't need to download this artifact right now. When we create an artifact, it's basically just an artifact within Bamboo. And then in the next stages, we will see that what things we can do with this artifact. You can upload it to a location, for example, to Amazon S3, or you can send it to the next stage for performing more work on it. We will see that soon. When you create an artifact, so let's go back to the plan and job configuration. So this was where we created this artifact. If I click on edit, as you see, I left the shared check mark checked. When you do that, this artifact can be shared across multiple stages. So in other stages, I can use this artifact. In the next section of the course, we will work on running unit tests. In this section of the course, we want to use variables in Bamboo. Variables in Bamboo are useful for parameterizing our builds and our artifacts. There are several types of variables. The first one is global variables. Global variables are defined by the user and are accessible across Bamboo instances as well as in all build plans. System variables are not defined by a user. They are accessible across Bamboo instances, and in all build plans, they get their value from the system or environment variables with the same name. For example, if I define an environment variable in Windows or in Linux and call it X, then within Bamboo, I will have access to a system variable called X. Plan variables are defined by a user, and they are accessible within the same plan. They override the global variables. For example, if I define a global variable called X with the value of 1, and then within the plan I define a plan variable called X but with the value of 2, then value of 2 will be used. Build-specific variables are evaluated by Bamboo and they are related to current build. We also have deployment variables. We will work with these in the deployment section of the course. They are available when we deploy a project. There is also a small set of variables called Jira variables. These are only available if you connect Bamboo to Jira. Every variable begins with a dollar and then a pair of curly braces. Name of the non-system variables begin with Bamboo. As you can see, the name of the variable will be a dollar and then an open curly brace, Bamboo dot, name of the variable, and then a closing curly brace. Format of the system variables is again dollar and a curly brace, but this time system dot name of the variable, not Bamboo dot name of the variable, and then a closing curly brace. Jira variables again begin with dollar and a curly brace, but then after Bamboo there is a Jira, so it will be bamboo.jira.variable name. Before we see some of the variables, let's have a look at our build plan that we already have. Under the compile and test stage and under the compile code job, as you can see, there are several tasks, and if you remember, the second task was for tagging the repository. In the tag name, there is a statement that I told you that I would explain later, and now I want to explain it. So as you can see, the content of the tag name begins with a dollar and an open curly brace, and that tells us that this is a variable. Soon we will see that what this variable means, but now we understand that for the tag name we use a variable, so every time we tag our revision in GitHub, we use a unique key and we want to use a duplicate tag name. Let's learn about some build-specific variables in Bamboo. The first one is bamboo.planKey. Plan key refers to the unique key of the current plan in the form of project's unique key dash plan's unique key. The next one is bamboo.buildNumber. Bamboo build number is sequential and begins with 1. If you run a build plan for 123 times, your build number will be equal to 123. The next one is bamboo.buildResultKey. Build result key is a very important variable, and that is important because it's unique and you can use that to name your artifacts or to tag your branches. It's got two components and two components are separated by a dash. The first one is basically your plan key. It's equal to bamboo.planKey. The next part is your build number. This is specifically useful if your project has more than one plan, because if you have two plans under one project and you run both of them 123 times, then you will have 123 as the build number of each plan. And then if you use that build number to name an artifact, later it will be very hard to understand which plan produced that artifact. So it's better to use build result key that includes the plan key, and then every artifact will be easily identifiable. Bamboo.buildPlanName is the name of the job in the project name dash plan name dash job name format. Bamboo.build.working.directory gives you the working directory of if you need to have access to the absolute path of your files, you can use this variable. As I said before, if Bamboo is connected to Jira, then you can use some Jira specific variables. I have specifically mentioned the Jira variables because they are very useful if you want to produce release notes or something like that automatically. As you can see, Jira variable names begin with bamboo.jira. The first one is bamboo.jira.base URL, which is the URL of your Jira application server. The next one is bamboo.jira.projectKey, which is the key of the triggering Jira application project. So if you trigger the build from within Jira, then the jira.projectKey tells you which project triggered the build. Bamboo.jira.projectName. Similar to project key, but this one gives you the name of the triggering Jira application project. The next one is bamboo.jira.version, which is the release version of the triggering Jira application project. And the last one is bamboo.jira.username, which is the username of the user that triggered the release build. In the next lecture, we will go back to Bamboo and use some of these variables. Let's see that how we can create variables. So the first type of variables that we learned about were the global variable. In order to create global variables, you must have admin access, administrative access in Bamboo. And when you have the administrative access, you will see this cogwheel on the top right side of the screen. And if you click on it, you can go to Global Variables menu. In here, you can create variables, and as you know, those variables will be available across all build plans. One example of the variables that you can create as a global variable is the base of a storage location. For example, if I want to upload all the artifacts that we want to deploy in the future on Amazon Web Services, then I can create a variable that points to the main AWS S3 bucket. S3 is the storage service in Amazon Web Services, and in the future we want to use it in order to deploy our artifacts. So for the variable name, I can use something like root S3 bucket. This is just a name, and the value will be the name of the bucket in Amazon Web Services S3 service. I put something in here, and then later we can go and create it in Amazon Web Services. For example, I can say Bamboo root S3 bucket, and then I click on add, then the variable is created. Now to access this, we simply say root S3 bucket. Now in order to create plan variables, you need to go to your plans and then select the plan. In the actions menu, we choose configure plan, and we have been here before. We go to variables tab, and then we can create variables in here as well. As you know, any variable that you create inside the plan is only accessible within that plan. Also, as you can see on this screen, if your variable name includes these words, password, SSH key, secret, or passphrase, the value will be turned to multiple stars just when it is displayed. And that's a security feature. One example of a variable is that for what environment we are building or compiling our code. The way we created our compile job in here, and we will go and see it soon, it compiles the code for the agent's environment. For example, because I'm using a local agent on a Mac OS machine, when I run the build command, it assumes that I'm going to execute or run the application on the same Mac computer, and therefore it just compiles it for Mac OS. But if we want to build the application and compile it for a different environment, for example, for Windows, then we need to use a switch or command in .NET build command. And because we don't want to hard code it, we can create a variable. For example, I can say there is a variable called target, and it can be Windows 64 or like Linux x64. These are predefined values for .NET build. And then I click on add. Now let's go and see how we can use this. So if I go to my job and then I find the build, you will see that in here there is a .NET build command, and it has an output. We can say -r. R means runtime, and it can be Linux -x64. But then this is hard coding the target environment. Instead, we can say $bamboo.target. When we run the build, this will be replaced by Linux x64. Now, if we want to build our code for a different target environment, for example, for Windows x64, we don't need to change anything here. We can just change the value of the parameter or variable. So if I go back to the plan, then variables, I just need to change this value. So by changing the value that we have assigned to a variable, we can basically use this value anywhere that this variable has been used. Also, if you remember, I said that plan variables will override the global variables. If you want to override a global variable, in the variable name, you see this drop down, open it, and then you see the global variables. You can choose it, and then you can provide a new value. For now, I'm not going to override this value. Similar to target variable, we could also use variables to, for example, tag the source code that you saw before. So $.bamboo.buildResultKey, as you know, gives us the unique key for this build. And there are other variables that we can use when we deploy our code artifact, and we will soon use them as well. In this lecture of the course, we want to learn about build triggers in Bamboo. So far, every time we wanted to run a plan, we open that run drop down in a plan, and then we clicked on run plan item. This is a manual trigger because we manually trigger a build. There are different types of triggers that we want to learn about. The first trigger type is a repository polling trigger. This is the default trigger, and every time you create a new plan, this trigger is added to your plan by default. The next one is a scheduled trigger that triggers based on a given schedule. Then you have single daily trigger that builds your plan every day. And you have a remote trigger that triggers the build based on code change detection. Now let's go to Bamboo and see how these work. Back to Bamboo. As I said before, in order to add triggers, you have to modify your plan. So I click on the plan, and then I go to Actions menu, and then I click on Configure Plan. As you can see, there is a tab here called Triggers. So I click on that, and in order to add a trigger, you click on Add Trigger. And these are the trigger types that we just learned about. So the repository polling is added by default, as I said. I had one here, I just removed it so we could add it again. So what repository polling does is that when you add this, and you can provide it a name, for example, repo polling, it pulls the code or it checks out the code based on a given either interval or a schedule. And then if there is any change detected in the code, it runs the build. You can assign this trigger to a given repository. Right now we only have one repository, but if we had more than one repositories, you would see them here, and then you could assign this trigger to a specific repository or to all repositories. By default, this trigger works based on a polling frequency. The default frequency is 180 seconds, which is 3 minutes. If you want, for example, this to work every 5 minutes, then you change the polling frequency to 300 seconds, obviously. If you want this to work based on a given schedule, you choose scheduled. The default schedule is 12 a.m., which is midnight, and this 12 a.m. depends on the time zone of your Bamboo server. If you want to edit it, click on this pencil or pen icon, and you can see there are different configurations you can use. For example, you can say, I want this to pull the source code on Sundays and Tuesdays and Saturdays, something like this. So that's days per week. And on each of these days, you can also provide time. You can also provide days per month or daily. And then you can say every hour, every 3 hours, every 2 hours, every 30 minutes. If you say, for example, every hour, then you can say every hour from 5 a.m. to 8 p.m. And then you click on Save Trigger. If you want, you can add even more triggers. So one of the triggers that is simple is called Single Daily Build. So it basically just runs your build at a given time. And I can say I want this to be at 13, which is 1 p.m. based on the time zone of the Bamboo server, and you click on Save. Again, you can add more triggers if you wish. You can add scheduled trigger. By providing a schedule, your build plan will be executed based on this given schedule, whether there is any changes in the code or not. So if I say, for example, I want my code to be built on Saturday, Sundays, it just runs the code every weekend. This might be a good practice because it allows you to build your plan and find any potential problems in the code on a weekend, for example, when the server is not busy and people are not working. The next trigger type is a remote trigger. Remote trigger is very important and is my favorite. What it does is that if we give it a name and we assign it to a repository, once I save this trigger, it just listens for changes. If a developer makes a change to the source code and then pushes it to the GitHub or Bitbucket or your any Git repository, that change then will trigger the build. This is a very good trigger because every time somebody makes a change, we build the code. Basically, we run the plan, which includes building the code. And if there is any problem, the build will fail, and therefore we don't go and deploy anything to, for example, your test environment, or we avoid merging the code back to the main branch. The last trigger that we want to learn about is a tag trigger. Tag detection is enabled by default in Bamboo. And what it does is that if we give it a name, it says that if any tags are detected by default, this means any tags, which is .star. But if I say a tag called tested, this means that if this tag appears in the branch that you're working with, then the build is triggered. This is a good trigger because then someone can trigger the build without having to commit any changes. And for example, if testers test your code and they say, yes, we are satisfied, they can tag that code and then that will trigger the build. When you add multiple triggers, just make sure that they don't clash, and also you add as few triggers as possible. For example, if you can achieve your single daily build with schedule build, then you don't need to add both. Just use schedule build that covers a single daily build as well. When you maintain your source code in a Git repository, your repository will have a branch called master. Master branch is called main in GitHub. When we want to create a new feature, it's a common practice that we branch the master branch, and we normally call them feature branches. Once the feature is developed, tested, and deployed, we merge that feature branch back to the master or main branch. There is also a scenario like this sometimes. Imagine that you have a product, but a customer says that I pay you extra so that you do custom development for me and you develop your software slightly differently compared to what you develop for other customers. In these cases, we don't merge the custom development branch back to the master. We merge the master or main branch to the custom development branch, so we get the common features as well as bug fixes to the custom development branch as well. We normally use a technique called cherry picking when we do this. As you can see, sometimes you may have branches in your source code that require a slightly different configuration and they may have different release frequencies. And because of this, Bamboo allows us to customize our build plan for each given branch in the source code. So if we have a look at the sample repository that we have used in this course in GitHub, it has a branch called main. This is equal to master, and it also has a feature branch called feature. Now, if we go to Bamboo and we go to Actions menu and click on Configure Plans, you will see that there is a tab called Branches. If I click on this Branches tab, what you see on the screen isn't creating a plan branch, it's configuring plan branches, and it affects the future plan branches that you will create. So the main thing you need to know is that how you create plan branches. By default, we need to create them manually by clicking on this button which says Create Plan Branch. But you can also request that every time Bamboo detects a new branch in your source code, it creates a plan branch for it. You can also customize it a little bit more and say that every time you detect a branch in the source code that its name matches a given pattern, and then create a plan branch. I prefer to create plan branches manually because, as you know, teams that use branches after a while will end up with so many branches in the source and nobody knows what the branches are and nobody can delete them. You don't want the same thing happen to your Bamboo. So it's better that we create them manually. In terms of deleting the plan branches, you can say that if the branch is deleted in the source control system, then delete it from Bamboo as well. You can provide a time, for example, 7 days after the branch is deleted in source control, deleted in Bamboo. Also, you can delete the plan branches in Bamboo if there is no activity on that branch in your source control. For example, if nobody commits a code or change to that branch after 30 days, then delete that plan branch. You can also automatically merge your branches in your source control, for example, in your GitHub. If the plan branches build is successful, then you can merge the branch back to the main or master branch by choosing this option. When we learn about notifications, we will come back and learn about this section of the plan branch configuration. Also, you can assign a trigger to this plan branch. By default, they use the triggers of the parent plan, but you can also change it. For example, if you want to say, I don't want to have any triggers associated with this plan, then just use none. The default setting is same as defined in parent plan, and I prefer to use this option. Or if you want to create new and custom triggers for the future plan branches, you can use custom triggers and then define a new trigger here. For example, you can define a single daily build trigger, something like this. So to create a new plan branch, we click on Create Plan Branch. Then if you open this drop down, you will see the list of branches, and I can choose a feature and click on Create. So the name of your plan branch is equal to your feature branch, but you can change it if you want. And if you want to overwrite the settings of your trigger, you can do that in here. Again, you can create a new trigger if you want to, and the rest is not much, and you can save it. So once you save it, you will see that there is an extra tab at the left side of the screen. So right now we are modifying the plan branch. In the branch details tab, you have the general settings, as you saw, the display name, for example. If we click on repositories, you see a repository that is copied from the parent plan. The only thing you can change about it is the name of the branch. Also, we can override the existing variables. So you can override the variables that are defined in your parent plan or the main plan, or even the global variables. So if you remember, when we were learning about the variables, we created a variable called target in this plan, and we used that to build our source code for Linux x64. Imagine that this plan is for a customer that wants custom builds and they use Windows. So you can overwrite the value of this target and call it Win x64. To see the configuration of the main or parent plan, you just click on Default Plan Configuration. So what you see here is now the configuration of your main plan. So if you want to go back to configuration of your child plan or your plan branch, there is a drop down up here, and then you open it and you choose your plan branch. Again, if you want to go back to the main one, you click on Default Plan Configuration. One last thing we need to learn is the dependencies. When you run the build for the main plan using the Run Plan option in here, as soon as the build of the main plan ends, whether some tasks fail or not, it will trigger the build of all the plan branches as well. So if you go to Dependencies tab in the main or default plan configuration and choose Trigger Dependencies only when all stages have been run successfully, then it will trigger the build of the plan branches only if all the stages in the main or parent plan have finished running successfully. That's a good item to choose, I would say. So what we learned today was that we can have one plan, one customized build plan for every branch in our source code. If you want to create a plan branch manually, you can do that from this little button up here as well. So if I click on it, it allows me to create a plan branch. That's a shortcut. That's good to know. Okay, so before working on the plan and project in Bamboo, let's have a quick look at our code in GitHub. So as you can see, there is a main project that is called Search API, and we had a test project as well in a folder called searchapi.test, and the project is called searchapi.test.cs project. So we want to compile searchapi.test.cs project. Back to Bamboo, we can go to our stage and to the job and keep adding a task. And again, for that task, we want to build the test project. So I choose a builder. In my case, because .NET isn't in the list, I use a command and I call this build unit test project. Executable is .NET, and I just paste the argument, which is build. The folder must be relative to current folder. So I put a // I'm using a Mac, that's why I use a // obviously in Windows you use a \/ and we need an output folder as well. I can say -o, and then again relative to the current folder I can say put this in like test output folder. Now we need to get the files in the folder that is called test output and put it in a new artifact. For that we can go to artifacts folder and create a new artifact. We can call this unit test artifact or test artifact. Let's say test artifact. And location is test output, and we want all the files. Now let's go and create a new stage. Configure plan. Let's create a new stage. Click on create new stage and we call this run unit test. Now in run unit test we add a job. Let's call it just default job. And then we add a new task. Because I'm not going to check out the code, I remove this source code checkout. If you want to check out the code and then run the unit test, you could have used this, but I don't want to do that. So I delete that and then I click on add task. In the search box, just type download and you will see that there is a task called artifact download. Click on that and you can name this like download test artifact, something like this. And then source plan is your current plan, and then choose the test artifact from the drop down list and click on save. Now we want to unit test this. In the next lecture, I will show you that how we can do unit testing. Now that we have managed to download the artifact that was produced by a stage called compile code to a new stage called run unit tests, we want to execute the unit tests, but we don't have that artifact yet, because if I go to the default job of compile and test stage, no artifact has been produced. So we need to run the plan first and then wait for the artifact to be produced, then we can use it. So as you can see, 2 artifacts have been produced. I just go to artifacts tab, and then as you can see, there are 2 artifacts. And I click on test artifact so we can see the content of that artifact. As you can see, there are a bunch of DLL files mostly, and that is because we compile the code. When in .NET you compile your code, you get a bunch of DLL. When you compile your code on a Linux-based operating system, I'm using a Mac, so that's why we get DLL. If you did this on a Windows machine, you would also get an exe file. So the DLL file that we want to test is called searchapi.tests.dll. Let's go back to Bamboo and to the configuration of our plan and create a task for running the unit test. So we click on add task, and for testing you click on the tests tab, and as you can see, there are a bunch of wrappers here. Some of these wrappers, if you pay attention, are called runners. For example, MS Test Runner, Mocha Test Runner, and so on. These runners can run your unit tests. There are also parsers. Parsers don't run the unit test, but they wait for you to write a script that runs the unit test, save the output of your test into a text file, and then they read the text file and they show the result in Bamboo. So that's all they do. They don't actually run the unit test. For this example, I have used a framework called XUnit. XUnit is from the family of JUnit and NUnit. It's a cross-platform unit testing framework, and it doesn't exist in this list. Every time something doesn't exist out of the box, you just create a new command, and we call this unit test. XUnit test can be run by the .NET executable. So we already have this executable. The argument for testing is test. So instead of saying run or restore packages, we just say test. And the file that we want to test was searchapi.tests.dll. And we click on save. Now I run the plan. And we will see that both stages pass. But if I click on tests, you will see that it says 0 tests in total. Although I had a unit test, it didn't find any unit test because the output wasn't parsed by Bamboo. This is okay if you just want to make sure that your unit tests don't fail and they pass. If you don't really care about seeing the output of the test runs, you don't need to do anything. But if you want, then we need to do something extra. Now let's go to GitHub and edit my unit test code quickly. So as you can see, this is a silly unit test. All it does is that it says 1 must be equal to 1. So it always passes. Now I change it to something that always fails like this. So I say 1 must be equal to 2. Now let's run the plan again. So as you can see, now the second stage failed. The run unit tests stage failed, and that is because if we have a look at the logs, our assert failed in here because 1 is not equal to 2. And at the bottom it says failed 1 passed 0. So the unit test was executed. However, again, in the tests, you don't see anything. We need to parse the output of XUnit if you want to see the output in here, and we do that in the next lecture. However, if you just want to run the unit test and make sure that if the tests fail, you don't just deploy this code, what we have learned up to here is perfectly enough. In this lecture, we want to see that how we can see the results of running unit tests in Bamboo properly. So for that, what we need is that we need to save the output of running unit tests into a log file. And therefore, we need to modify the task that was running the unit test. So the command was a .NET and then test, and then the name of the DLL file that included the unit tests. This doesn't save the results into any files. So we need to add more parameters to log the output. To log the output, we can use --logger that will basically start logging into a file. And then in quotation, the first part is the format. So XUnit and JUnit and NUnit, they can output the logs into different formats, for example, XML and HTML. The one we need is for MS Build, and that is called TRX. And then semicolon, and then you just need to say log file name equal to, and then provide a name, for example, test results.trx, and then we save. After that, we add a new task, click on tests, and then make sure you pick a parser, not a runner. So in our case, we want to use MS Test Parser. And then we provide a name, for example, parse test results. In the MS test results file or directory, you can leave the pattern as it is. It will find all the log files and show them in Bamboo, or you can just remove this and use test results.trx. I recommend that you just leave the pattern so it files all the TRX files for you. And then we click on save. Now we can run the plan. Also, I modified the test case so that it will pass. So again, we get that green bar. I click on the run unit test stage and then the default job, and then I click on tests. Now you will see that it doesn't say 0 test. It shows 1 test in total and then the name of the unit test. And if I click on it, it exactly explains the test class and test method, and everything will be here. That is it. It's important to see the details of a unit test run in Bamboo, because in case the tests fail, your development team will be able to understand the potential problems that exist in the code. In this lecture of the course, I want to show you that how you can perform code analysis or code inspection as part of your CI and CD process. There are many different tools for analyzing the quality of the code. Because my project is a .NET project, I have used a tool called ReSharper Command Line Tools. So the Command Line tool is a free tool and it doesn't require a license key. As you can see, it's mentioned on their website as well. You can run it on Windows, Linux, and Mac OS. Because I'm using a local agent on a Mac computer, I just downloaded the Mac OS version. Once you download the package, it will be a zip file, and all you need to do is to extract the zip file. Inside the zip file, there is a file called inspect code. Inspect code.exe is for Windows, so if you run this in Windows, you need the exe file. On Linux and Mac, you use the sh file. So we need the path to this executable file, so I just copy the path to inspect code. And we go to Bamboo and we go to our agent. So I just go to agents. I click on my local agent and we need to add a new capability. So the capability is an executable. It's a command. We can call this code inspector or something like that. And we paste the path to the executable file. So the executable file is also included. It's not just a directory. And I click on add. Then we can go to our project, to our plan, and modify the plan. So I go to configure plan. Obviously, to inspect the code quality, you need to have access to the source code within your stage. So in the test stage, we don't have the source code. One option is that we add a new stage and then check out the code, or we just go to the compile and test stage where we had access to the code, because obviously the first task checks out the code, and then we can add a new task to run the code inspection. To start, we can add a new task. This task is going to be a command, and we can call that something like inspect code or analyze code or code analysis. And the executable will be the code inspector, and the argument will be our solution file or project file For example, search api.cs proj. And you also have to provide a log file name. So the output has to be a log file name. So for the output, you use -o and then a colon and then some name. For example, inspection result or results.xml. So all the warnings and errors and hints will go into this XML file and we save. Now we need to find a way to parse the output, which was that XML file, and show it in Bamboo. So there is a task called a warning parser. So if I add a new task and just search for warning, you will see that there is a task called build warnings parser, and you just need to add that. And we can call this like warning parser or parse. Then you choose your compiler or code inspector. There is a long list of code inspection tools or compilers that generate warning and also are able to store the output in a log file. Unfortunately, tools such as SonarQube are not seen in the list for now. However, ReSharper Inspect Code is in the list, so we can use this. Also, Ansible and Java compilers and many other things are here. For example, as you see, Eclipse is here, Maven is here, MS Build for .NET is here, PHP Runtime. There are so many tools that you can choose. Some of the ones that are my favorite ones, unfortunately, are not in the list. So add this task and then see what compiler or code inspection tool is available and then use that. So for us, it's ReSharper Inspect Code. If you have multiple repositories in your job, you can associate this inspection with a specific repository. So it wouldn't try to inspect the code of any other repositories. It will only inspect the code of a given repository. Our job has only one repository checkout or source code checkout. So we don't need to associate this. And choose parse files. Either provide something like *xml or put the name of the file. So our output file was inspection results.xml. You just put it in here and you click on save. Now let's run the plan and then see what happens. Okay, now as you can see, the build was successful. However, you see an extra tab. And that extra tab below the test tab, it shows 6 medium severity problems or warnings and 5 low severity warnings or hints and 0 high severity problem. So it gives you an indication as to how well the code has been written. You can set a rule and say if I get more than 5 medium severity problem or more than 2 high severity problems, then break the build. For that easily, you can configure the plan again and then go to your task and check the fail build if too many warnings are found. The first option says, regardless of whether the severity is low, medium, or high, if there are more than, for example, 5 warnings, just break the build, fail the build. Or we can say if more than 2 high severity problems or warnings, or more than, say, 4 medium or high severity problems, then fail the build. Now let's build the project again. So this time, as you can see, the build failed because obviously we have 6 medium severity warnings and 5 low severity warnings. And we said that if total of these two are above 4, then fail the build. This is good to make sure that you are not deploying a low quality code and you stop the deployment and build and deployment before the code ends up in your production environment. In this section of the course, we want to work with the deployment projects. Deployment projects help us release our artifacts. The normal process of releasing an artifact or a release process is as you see on the screen. Normally, you have an issue management system such as Jira, and you create a ticket in it. For example, you create a user story if you use an agile methodology. And then based on the requirements mentioned in that ticket, you make code changes and then you test it locally and then you commit your code changes back to the source control system, for example, back to GitHub. If you have set up a remote trigger that triggers a build, or you trigger the build manually, the build plan, as you have seen so far, builds the code, tests it, runs code quality checks, and produces artifacts. We have done the whole process up to here. We have learned it and we know how that works. Now, once you have the artifact, you want to deploy it to different environments. For example, you may deploy it to a sandbox environment and you test it yourself. And then if you are satisfied, then somebody, for example, your test manager, deploys exactly the same artifact to a different environment, for example, to staging or testing environment. And once the test manager indicates that he or she is satisfied with the quality of the artifact or the software, someone with authority, for example, your team lead or tech lead or the release manager or product manager, will deploy exactly the same artifact to your production environment. So as you can see, one part of the process, which is the CI, continuous integration, allows you to make changes and then builds and tests the code and then creates the artifact. But there is a CD or continuous deployment aspect to it as well. And we manage that CD or continuous deployment using the deployment projects. There are many benefits for having a deployment project in your Bamboo. The first one is that artifacts must be deployed to different environments, as I just mentioned. For example, to sandbox, staging, or production environments. And access rights that are required for deploying to different environments can be different. And also the roles of the people in the organization that work with the continuous integration can be very different to those who work and manage the continuous deployment. For example, developers manage the continuous integration, but then product managers or release managers manage the continuous deployment part of the project. Deployment projects also enable us to have consistent deployments across multiple environments. As I said, because we create one artifact and we deploy it to multiple environments, that allows us to have a consistent deployment and making sure that if my software works perfectly in a staging environment, it's the exact same software that goes to production environment. And we can also implement manual approvals. So normally before deploying something to production environment, we need someone with authority, for example, a product manager, to manually approve the deployment. And we can do that in Bamboo. And also Bamboo allows us to roll back the deployments if something goes wrong. So let's go to Bamboo and work with a deployment project. In order to create a deployment project, we need to configure our plan and be on the Stages tab. As you see at the bottom of this Stages tab, there is a button called Create Deployment Project. And if we click on it, then we can create a new deployment project. The name of the deployment project is normally Deployment 4 and then name of the plan. But you can change this to anything you want. For example, I can just call this Deployment Project. By default, you are the only user that sees this deployment project. However, if you check this checkbox that says allow all users to visit this deployment project, other users will see this deployment project as well. It doesn't mean that they can run this deployment project or modify it. They can just only see it, and later you can modify the permissions and then decide what user can do what with this project. You can link this deployment project to a child plan. So by default, it's attached to your main plan. But if you want to attach it to, for example, the plan that we created for a feature branch, you can use that as well. And then you click on Create Deployment Project. If you want to edit what we just did, again, click on Edit Build Plan and you go back to the deployment project details. The next thing you need to set up is release versioning. So every time you run a deployment project, you are making a release, and every release will have a version number attached to it. So I click on release versioning. By default, the label is like this. Every release will be named release dash and then a number. This number is sequential. So the first time I run the deployment project, it will be called release 1. And then next time I run this deployment project, it becomes release 2. You can also use a variable. Any variable you want, you can use. However, obviously every release version must be unique. So for the variables, you can click on add variable to version and you will see a list of variables. At the top, there are the variables that you have defined. And then the build variables of Bamboo are at the bottom. And for example, you can use the build number, or you can use the build key, or build plan and build name as you want. So we can use the build number by clicking on add variable. So if I remove this one in here, then the release will be release dash and then release build number. We can also generate a preview and it shows it at the bottom. And then we click on save. This checkbox can only be checked if you are not using a variable and you want to use sequential number like 1, 2. But because we want to use a variable name, we need to remove this checkbox and then we save. As I said, just because other users see this deployment project, it doesn't mean they can run it or modify it. You can edit the permissions by clicking on project permissions. So this John Doe is the user I have logged in with and I'm the owner, so I can view it and edit it and everything. And if you have groups or users, in the administration section of this course, we will work with the groups and users. If you have groups and users, you can also add them by searching for them here. Their name will appear just like John Doe, and then you can say this group can view or view configuration or edit configuration. Logged in users and anonymous users can only see this deployment project. For example, I can remove this checkbox. So anonymous users means that users that are not logged in cannot see this deployment project. And then we go back to the deployment configuration. Bamboo spec repositories is something a bit advanced. We don't use it now, and that is that you can code your deployment project in languages such as Groovy or Java and store it in GitHub, and then you can attach it here to this deployment project, and then the entire deployment project will be created based on the code. It's too advanced for what we are doing right now, so we don't do it. Also, audit log will show all the changes someone has made to this deployment project. This is very useful if you see that your deployment project is not working as expected, or some settings might be off, and then when you deploy your project, you see that it's not really working properly. You can come back and see full history of all the changes that users have made to this project, and you may be able to identify the problem. That is it. The next part is adding environments. To add an environment, obviously we click on add environment and we can name them. For example, we can call this sandbox. We can also create an environment, call it production. So as you can see, now I have two environments. One is sandbox, one is production, and the same artifact can be deployed to two different environments. So as you can see, in every environment, for example, in sandbox, we need to set up some tasks, and using these tasks, we are able to deploy the code to this environment, and we have to set them up differently. The way I do it is that I only create one environment, like sandbox. I set up all the tasks and everything, and then I go to actions menu and clone it. And then I just give it a new name and I tweak it a little bit for the target environment. But if you create all the environments first, then you have to set up all the tasks 2 or 3 times, which is not fun. So create one environment and set it up completely, and then just clone it as many times as you want. In the next lecture, we will start working with the tasks and see that how we can deploy our source code to multiple different environments. Now we want to continue working on our deployment project. For this deployment project, I want to use Docker as an example, just so that you have an idea as to how we do deployments. So because I'm going to use Docker on your build agent, you must have Docker installed. If you haven't done that before, simply go to docker.com, choose your operating system and click on Get Started. Once Docker has been installed, then you need to restart your server or your computer, and then you will have Docker Desktop on your machine. The second step is that once you have installed Docker, you need to add it as a capability to your build agent. So if I go to agents in a new tab, you will see that I have a local agent, and in the list of capabilities, I have Docker that points to the executable file of Docker. In Windows, this Docker will be docker.exe. So if you don't have a Docker capability, simply find where your Docker file is or your docker.exe file is, add a capability and choose Docker as the capability type, and then provide the path. So if this was Windows, it would be like docker.exe at the end. So search for docker.exe to find where it is and put the path plus the file name in here and click on add. Then you will have a Docker capability. Without this, you cannot do anything inside Bamboo with Docker. So for this example, I click on edit tasks and you will see that as soon as we create a deployment project, 2 tasks are added by default. The first one deletes all the files in the working directory so that if you have run this project before and you have files from the past deployments, you don't deploy old files to your, for example, production environment. And the next one is artifact download. Obviously, we want to deploy an artifact, so we need this. By default, it downloads all the artifacts, but we don't want to deploy the unit tests. We just want to deploy our search API, so we can just choose one of them. If you want to download all the content of your artifact into a subfolder, you can provide a subfolder name in the destination path. And then you click on save. The next step is to deploy these files. So if you click on add, all the deployment related files are under deployment tab. And as you can see, we have artifact download that we have already used. If you want to deploy 2 EC2 instances on Amazon Web Services using AWS Code Deploy service, you can use the AWS Code Deploy task. For deploying Docker, you can use Docker. This is what we want to do. Also, if you are a Java developer and you want to deploy to Tomcat, you can use the Tomcat tasks such as deploy Tomcat application, reload application, stop application, start application. Also, it has 2 tasks for iOS developers. You can deploy your app to Hockey app and TestFlight. So for this example, first of all, I want to create an image, a Docker image. So let's add the Docker task and say build Docker image. In the command, I choose build a Docker image, which is default. We can also run a Docker container, push a Docker image to a repository, for example, to Amazon Web Services, to Azure, or to Docker Hub, or download or pull a Docker image. So we need a repository name. I want to push this image later to the public Docker Hub. So I need a repository name. For that, I need to go to hub.docker.com. I must have signed up and then signed in. So as you see, I'm already signed in. And I click on repositories and I click on create repository and I provide a name, search API. And it has to be public because I'm using a free account, and I click on create. So every time you create or push a Docker image, it has to have this format in the repository name. So this is your account, this is the repository name, and this is a tag. Tag is optional. It's normally the version. So I can use this in here. Now for tag name, it has to basically be version every time you deploy. So best thing is to use build number or something like that. So I can use a variable and say bamboo.build number. Now I need a Docker file. So a Docker file is a container of instructions for Docker that tells Docker how to create this Docker image. The Docker file that we want to use is very simple. It's this basically. So what this does is that it downloads the image of .NET that is called .NET ASP.NET. This is basically the runtime of ASP.NET. This is the tag that points to version 7. mcr.microsoft.com is the Docker registry of Microsoft. MCR stands for Microsoft Container Registry. Then we create a path called app. We copy all the files in the current folder. Current folder points to the working directory of this project. And we have already downloaded the content of the artifact here. So all the content of the artifact will go into our container. We expose port 80 because this is an API. And also this entry point is a command that we run at the end so that the API can listen on this port 80. And that's it. You need to copy this into clipboard and paste it into this box. If you want to pass extra environment variables, you can do it in here and then save. Now let's go back and deploy this to Sandbox. So if I open my Docker desktop, there should be an image here. So as you see, it says Bamboo course, search API, tag is here, 24. So the next step is to push this to a repository. For our example, we want to push it to Docker Hub in here. In your company, probably you push it to AWS repository or to Azure or something like that. But the Docker command is always the same. So if in your company you want to deploy this to AWS, AWS will give you exactly the path that you need to use for your repository, and you use that. So in the next lecture, we will push this to Docker Hub. Now that we have created a Docker image, we want to push that Docker image to a Docker repository. For this course, I want to push the Docker image to Docker Hub, which is the repository of docker.com. If you push your image to AWS or to Azure or Google Cloud Platform, they have their own repositories of Docker images, and therefore they provide you with the URL of the repository, and you just use that instead of hub.docker.com. Before we can push anything to hub.docker.com, we should be able to log into it. So with a user that has the administrative rights, open the admin section of Bamboo, then click on shared credentials. In order to log into hub.docker.com, we use a username and a password pair. If you want to push your Docker image to Amazon Web Services, instead of username and password, you will need an access key and a secret key, and then you would put it in AWS credentials. So I click on username and password. Credential name is Docker Hub, for example. My username is the account name, which is Bamboo course. I just type it here, and password, and then save credentials. Before we go back to Bamboo, also remember the name of your repository, which is Bamboo course search API. Now we go back to Bamboo and we add a new task, deployment, Docker, and we call this push to Docker Hub, for example. The command is not build a Docker image anymore. It is push a Docker image to a Docker registry. Something very important for you is that if you have an application in Amazon Web Services, for example, in Amazon Elastic Container Service or ECS, in Kubernetes or in Azure, all you need to do is to deploy your application or artifact is to push the Docker image to the Docker registry. And then there will be either an automatic trigger to deploy that image within AWS or Kubernetes, or you just do that using a command that you send to AWS or Kubernetes. So building a Docker image and pushing the Docker image to a Docker registry is basically 90% of the job that you need to do in order to deploy your application as a Docker container. That's why we work on these two. So the registry is Docker Hub. The repository is basically this. Also, you need to provide a tag, and as you remember, we use the bamboo.build number as our tag, so we can again use the same variable in here. For authentication, use shared credentials and use the one that we just created for Docker Hub, and click on save. Now let's run this deployment. Okay, the build and push were successful. Now if we go to our repositories, you will see that there is one image in here already. Now we can use this image to basically create containers either locally or in our network. Just so that you can see that our deployment works, I'm going to click on see all, and then that gives you the pull command, and we can use this to pull the image and then create a container out of it. So I just open terminal. So first of all, Docker image list. There is one image already. We should delete it. It's easier if I delete using Docker desktop. So I just delete this. Okay, so we don't have any images and any containers. Back to here, I can just use this command. So we pull the image from Docker Hub this time. Now if we say Docker image list, we have this image that came from Docker Hub, and this is the image ID. Now I can create a container with Docker run. We need to do a port mapping because port 80 is busy on my machine. So we can say something like 9100 maps to port 80. The first port is on my machine and the second one is the container port, and then we just put the image. So now let's go to a browser. First of all, let's have a look at containers in Docker. You will see that one container has been created. Now let's see if this works. We can go to, and the endpoint was search. So as you can see, it returns something. Don't really worry about what this is. This is basically just an empty message produced by .NET. This API doesn't do anything. It just returns OK. As you can see, status code 200. But it shows that our code was deployed within a Docker container and it actually works. So Docker is very common for deploying microservices and applications. I highly recommend that you consider using Docker using the instructions that I just provided. In the next lecture, we want to deploy an AWS Lambda to AWS using Bamboo's deployment projects. And we want to do that so that you can see how we can deploy something without one of the built-in tasks of Bamboo, because obviously in the task section, there is nothing for deploying AWS Lambda. And for that, we will use some sort of scripting as well. Before we wrap up this lecture, as I said before, now that we have one environment called Sandbox that has all the proper tasks and it works, for production, what you need to do is basically just to clone it and call it production. So always create Sandbox and then clone it for production. Then you can edit this for the parameters and for configuration that you use for production environment. In this lecture of the course and in the next few lectures, I want to show you that how we can deploy an AWS Lambda to AWS. AWS Lambda functions are very common and that's why I have included their deployment in this course. We will work with several AWS services, including AWS Lambda service, AWS CloudFormation service, and AWS S3 service. AWS Lambda is the serverless microservice. AWS CloudFormation is responsible for creating AWS resources, including AWS Lambda functions. And AWS S3 is the storage for the artifact that we will create using Bamboo. And this is how they are related. So we have a build plan in Bamboo that creates an artifact and we upload that artifact onto AWS S3. Then CloudFormation downloads that artifact from AWS S3 and then based on that, it creates the AWS Lambda function for us. To make this happen, we need to use AWS command line interface or AWS CLI. You have to install AWS CLI on the build agent and add it as a capability to your build agents. So as you can see, now we see the capabilities available in my build agent. And as you can see, AWS CLI is already there. If you don't have it, just download AWS CLI. All you need to do is to Google AWS CLI, download it. If you are on a Mac or Linux, that's the path always. USR local, AWS CLI, AWS. If you use Windows, just search for aws.exe and then use the path and the name of the file for your capability. We will need to use AWS CLI to initiate commands. Also, let me show you the configurations that I have created for us. So in GitHub, I have created a new application called Bamboo v2 _sample app2. It has two files. One of them is the source code of the Lambda function, and one of them is the CloudFormation file that we want to use to deploy this Lambda. We can see the content of these files here. So lambda.py is the Python code of the Lambda function. It's very small and it only puts out the hello world message. Then we have this file instructs CloudFormation to deploy the Lambda function, and it's got three parameters. Artifact name is the name of the artifact that will be produced by Bamboo. Lambda name is the name of the Lambda function, and S3 bucket is the name of the bucket on Amazon S3, and we will upload the artifact name on that S3 bucket. Then this Lambda function under resources instructs CloudFormation to deploy the Lambda. So what we will have here is basically just the name of the S3 bucket where the code is, the name of the artifact, the runtime is Python 3.11, and that's it. It's not complicated. So we will use AWS CLI to ask CloudFormation to read this deploy CFN file and then deploy this Lambda. Before we go ahead, let me just show you one more thing. If you remember, when we learned about global variables, we created a global variable called root S3 bucket, and that was Bamboo root S3 bucket. I used this already to create a bucket in AWS. So in Amazon S3 service, I have already created a bucket with this name. and we will upload the artifact in this bucket so CloudFormation can read it. And also we don't have any Lambda functions. Once we deploy the Lambda, it will come here. Also, there is no CloudFormation stack. Every time we run the CloudFormation and we ask it to create resources, it will create something called a stack. A CloudFormation stack includes all the resources that are created based on the script that we have passed to CloudFormation. And that is good because then if we delete the stack, all those resources will be deleted altogether. Or if we update the stack, everything will be updated. It keeps it atomic in some ways. And that is it. I will link the URL of this GitHub repository to all these lectures so you can have access to it. And then we can start by creating a new Bamboo plan in Bamboo. Let's do that in the next lecture. The next step of deploying our Lambda function is to upload the artifact to AWS S3. So as I showed you before, I have created a bucket in AWS S3 or Amazon S3 service, and we want to upload the file in here. Obviously, we need to authenticate first and we need to have enough access rights. For authentication, there are two options. If you have deployed your Bamboo build agent on an AWS EC2 instance, you can assign a role to your AWS EC2 instance that has enough access and privileges to access the AWS service or other services that we want to use. If you have deployed your Bamboo agent in other ways, then you need to have a user with enough access, and then we use the credentials of that user. For that user, you need to go obviously to IAM service, Identity and Access Management service, and create a user. I always have a user that I use for programming access. It's called programs. That's the name of the user. It's got an access key and a secret key, and I can use this access key with the secret key. My user has administrative access, so it has all the access, but if you want to work with S3, obviously you need to provide write access, which is I think called put object to S3, and also same for Lambda and other services that we want to use. There are two ways of using access key and secret key. For the deployment tasks or any other task that is out of the box and it's created for accessing AWS, for example, if I just go to the default job and add a task, and this task, something that works with AWS, for example, AWS code deploy, then for the credentials, we can use a shared AWS credential, and I'll show you how we create that. But because we are going to use command line, that way of creating the shared credentials is not going to work. So the AWS shared credentials is in the admin section of Bamboo under shared credentials. Add new credentials and then AWS credentials. As you can see, I can put my access key and secret key in here, and automatically they will be used by any task that is designed for Amazon Web Services. But if you want to work with command line interface, then we need to pass the access key secret key to the command line interface directly. For that, there are many ways of doing it. One is that we can create variables and use that. For example, we can create a variable at the plan level. So if we say configure plan and then we go to variables, I can add two variables. One variable will be for secret key and one variable will be for access key. So for secret key, use one of these in the name, for example, password, secret, or passphrase, so that it gets hashed automatically. So in the variable name, I can say secret key, and then you see this show button appears here. That's because it gets automatically hashed. And also then we can say access key. And we get the access key from here. That's it. Now we have access key and secret key as variables. We can pass them to AWS CLI. Now let's go back to the Stages tab and click on Create Deployment Project to create a deployment project. And we need to give it a unique name. So that can be Deploy Sample App Lambda, something like this. And the build plan is the Lambda deployment. We create this, we add a new environment, and we can call this like QA staging, something like this, like QA. And we start setting up tasks. The first task is cleaning up the local folder, which is fine, and then artifact download. We want to download the Lambda artifact in the current folder. And then we want to add a new task for copying this to S3. So the easiest thing you can do is to create a script task. If you have installed your Bamboo build agent on an EC2 instance, you can use the role that is attached to EC2 instance, and therefore you can easily use the command and use AWS CLI command without passing any credentials to it. But if you haven't done that, we need to create a script task so that we can pass the credentials to the shell. Shell is the environment where a script or command is executed. So we need to create the credentials inside that shell. So the task description is upload to S3. And for the body, we need to create environment variables. You create the environment variables in Windows with set command like this. In any Linux or Mac computer, you use export. I'm on a Mac, I use export. So the environment variables that we need to create are access key, secret key, and region. So I say export, and your access key, secret key has to be capital letter because that is how AWS CLI finds them. So access key ID, and then we have export, and then we need the secret access key, and we need export and then region. My region is AP Southeast 2, that is Sydney. Now for the value of access key and secret key, we can use the variables that we created. We can say bamboo dot access key, and for this one, bamboo dot secret key. Now we can use the command. We can say AWS S3 service. We want to copy a file. File was called lambda py, and we want to copy it to S3 $, and the variable name was root S3 bucket. So bamboo root S3 bucket, and that should work. Now let's go back and deploy this. Okay, it succeeded. If we go to S3 and refresh, the file is here. In the next lecture, we want to write another script and then just execute the CloudFormation so that it deploys this file as a Lambda function. Now we want to deploy the file that we uploaded to AWS S3 using the CloudFormation service. And for that, we click on Edit Tasks so we can add one extra script. Before adding a new script, I copy the content of the script that we wrote for S3 because I'm going to reuse the top part of it. So I add another task. It's a script task, and we can call this make stack, something like that. And I paste the body in here. I keep the top part where we created the environment variable, so I don't have to do it again. I also save this variable. We need to use it. Now, we need to use AWS command line. The service is CloudFormation, and the command is create stack, and the stack name will be anything like bamboo. Then we need to provide a template body. Template is either on S3 or on the local disk. When we want to use a file that is basically on the disk, we use a file. Otherwise, you have to use S3 or HTTPS. So our deployment file was this deploy cfn.yml. So that is the CloudFormation template. Deploy cfn YML. Then we need to provide parameters. Parameters must be in quotations and they have to be separated by a space. And they are like this. We say parameter key. The first parameter was artifact name, and then lambda name, and then S3 bucket. So artifact name, and then comma, parameter value. It has to be the name of the lambda file. So that was lambda. One space, because we need spaces. Again, we say parameter key, and the next one was lambda name. Parameter value, it can be anything. Again, one space, parameter key, S3 bucket, and parameter value. This time we want to read the parameter value from the global variable that we created. And we also need to provide a capability because our CloudFormation template is creating a role. So we need to say capabilities, and that is a standard capability. It is always capability named IAM. Now we can save this, go back and deploy this. Now it's successful. The create stack command doesn't wait for the stack to be created and be finalized. So if I click on Bamboo, we can see the events and we can see that the Lambda role is being created and the Lambda function is now being created. And I think now everything is created. So as you can see, status is create complete. So if we go to Lambda, there should be a Lambda in here. Yes, this is our Lambda function deployed. And this is the code. It matches the code we had in GitHub. And if you want, you can also test it, but it doesn't really do much. So as you can see, it returns hello world. So we managed to deploy our Python microservice or Lambda function to AWS from Bamboo. The last thing we need to learn about the deployment projects is setting permissions and decide who can deploy your artifact to a given environment. Because obviously a developer or a tester shouldn't be allowed to deploy to your production environment. Deployment to production requires a level of authority that normally a product manager or a technical lead has. And also a developer shouldn't be allowed to deploy to your QA or test environment, because if your testers are performing tests and a developer releases a new version of the software, all the tests that your testers have done becomes invalid. So for that, we need to set proper permissions. In the deployment projects, there are two levels of permissions. One is the project permissions that sets the basic permissions for your deployment project. Then per environment, you have environment permissions. And you have to set both project permissions and environment permissions properly for things to work. If you only set project permissions, you can only see the environment, but you won't be able to deploy to it. And if you only set the environment permissions and you don't set any project permissions, you won't see any projects or plans at all. So we need to set both. So for this lecture, I have created a user and a group. We will have a topic about users and groups. But for now, I will show you that I have created a user called test manager. And also this test manager is in a group called QA engineers. Now we want to give this person permissions. So as I said, first we have to set the project level permissions by clicking on project permissions button. So this John Doe is me. I have logged in with John Doe and I'm admin. And then if you want to provide access to a group, click inside this drop down and then type the first letter of your group name. The group comes up, QA engineers. Then in the next drop down, select the level of permissions. For example, view configuration and edit. And then click on add. If you wanted to provide permission to an individual user, do the same thing, but with the users drop down at the top. For example, if I type T, test manager comes up and then I can assign a permission to this individual. It's much better that you assign permissions to groups. It becomes a lot easier to manage. Also, you can decide that if someone has logged in but is not in any of those groups, what they can see or do. So as you can see, there is no deployment permission here. This is only at the project level. After setting up the project permissions, we click on environment permissions, and then now we can provide permissions for groups or individuals, but this time we can give it more granular access, for example, deploy or edit. So again, for example, here I say QA engineers group, and in the permissions now I have the deploy option as well. And then I add. Now I sign out and I sign in again, but with test manager. So as you can see, I see the projects. I can go to deployment projects. There is one deployment project here, and I have the deploy option here. Now let's go back with admin. And we go to configure plan, deployment project, and then edit. And we go to environment permission and we remove this deploy. See what happens. Again, I log in with Test Manager. And this time, there is no deployment button. I can only view. Even if I go in here, there is no deployment button. So by providing permissions, you can control who can deploy, who cannot deploy. In this section of the course, we want to learn about the administrative tasks that we can perform in Bamboo, and we want to start with managing users and user groups. So to see the users and users groups, obviously you have to be logged in with a user that has administrative privileges. Then you click on this cogwheel and then you click on Overview. And under security category, you will have users and groups. So if you click on users, you will see the list of current users. And if you want to create a new user, you will click on Create User. Every user must have a unique username. For example, we can call this Dev Manager. And every user must have a full name. I used a random full name generator and that gave me this name. And then you can provide an email. For example, I can call this b.g@example.com and a password. Then I click on Save and my user is now created. Every user can be added to one or more groups. If you want to add a user to a group from the users page, you can open this groups drop down. You see the groups and then you can choose what group you want to assign the user to and then you click on add. Also, you see on the screen, it says failed CAPTCHA attempts. So when a user tries to log in, if they enter the password incorrectly multiple times, Bamboo will generate and display a CAPTCHA, which is normally a random text you have to enter back in. And then that will show you how many times a user has tried to enter a password and failed. And that is useful if the account is locked and you want to unlock it. You can have a look and see if they may need to reset their password. The other thing you need to know about the users is the repository aliases. So your username in GitHub or in Bitbucket or any Git repository might be different to your user in Bamboo. When you make a change, let me show you, in your source code, and if you have a remove trigger, that remove trigger will pick up the changes that have been committed to GitHub. For example, as you can see, my Lambda deployment plan has picked up a change that my user in GitHub has submitted, and then it has triggered this build. And as you can see, it's not showing John Doe in here. So this build was triggered manually, so it shows my username in Bamboo. This build number 8 was triggered by a code commit in GitHub. It doesn't show my user in Bamboo because when you check in a code in GitHub, you may not be logged in Bamboo, or you may not even have a user in Bamboo yet. So there is a feature in Bamboo that allows us to map a user in GitHub to a user in Bamboo. The user in GitHub can be identified in Bamboo when the user commits a change to GitHub or to Bitbucket, and then Bamboo picks up that change. Then every time a user is identified, their username or email address is stored somewhere. We call them authors. So you can say that, for example, this user in GitHub is actually this dev manager user in Bamboo, and you can map them together. You can also map to more than one user. By doing that, you will see the actual username and not just the email address. So as you can see, now the emails are gone and it shows Bethan Green, that name that we assigned to this user. So if you want your build information to be cleaner and you see the actual name of people who exist in Bamboo, you can assign them to repository aliases. The next thing is groups. Groups are very simple. You can create one group with a given name, for example, tech managers, and then you can add people to it. So if you open this drop down, you see the list of users. You can also search for them, like if I type John Doe comes up, and I can add it to tech managers. And then you can use this group to send a notification to all the members of this group, or you can use that to set permissions. So the next thing I want to show you is the global permissions. We have seen already how we can define for projects and for environments in the development projects. In this section, you can define a blanket rule. So this is like a template that every time you create a plan or a deployment project, these permissions are inherited, and then you can modify them at the project or plan level. It has 3 sections. User access section is for providing access rights to an individual user. For example, if I type B, Ethan Green comes up, and then you assign permissions such as access which means that they only access Bamboo. Create, they can create plans. Create repository, they can create repository. Admin means that these are admin users. You can add. If you want to provide access to a group, then in this drop down, you look for the groups and you can type, for example, T, and then tech manager comes up. And then again, you set permissions. For example, tech managers can access, create. And then others include two types of users. So logged in users are users that are logged in, but they haven't been defined in the group section or in the user access section. And anonymous users are users that are not logged in. You can remove the access for people who are not logged in completely. And for the logged in users, you can say they have access, but they cannot create or admin, or we can say they can create, but they cannot admin. As I said, when you create a plan or a project, then these permissions are applied and then you can customize them at the plan or project level. In this topic, I want to show you that how you can configure a mail server in Bamboo so that we use it for sending emails as notifications to users. So for this lecture, you need an SMTP server, an email server. If you already have one, obviously use that. If you don't, there is a service called Mailtrap. The website is called mailtrap.io. And you can sign up for free and get a free plan. With this service, which I already have and I have already logged in, it will give you an SMTP server, for example, like this one, and a username and a password. So you will have a host and username and password. And then when you send emails from any address to any address using this host, they will appear here. So they won't go to an actual mailbox anywhere. They will appear here. And this is a perfect service for testing. And we want to use this. So how do we configure a mail server in Bamboo? Obviously, you need to be logged in with a user that has administrative access. We click on this cogwheel, we click on overview, and we scroll down to mail server here. You can provide a name, and from address can be, for our case, anything. For example, bamboo@example.com. Then SMTP server will be in here. So that is our SMTP server. We put it in here. Username again is here. And password is also here. We can send a test email now. We can say user@example.com, save and test. Now let's refresh this. So as you can see, the email appeared here. So now we can use this email system that we configured for sending notifications. So how do we send notifications? For sending notifications, we have to go to our build plan, for example, Lambda deployment plan, configure the plan, and then as you can see in these tabs, there is a notification tab. We click on add notification and then you choose an event. If you want to get an email for when the builds are completed, you choose this one, that is the default. If the build status changes, you want to get a notification, you can choose this one. This will send you lots of emails because every time you go from like compiling to success or to fail or to test, you keep getting emails. Also, if you want to get notifications about failed builds, you can use this and so on. And also the recipient can be a user or can be a group or can be email address. So a user can be selected from here. For example, if I say A, then admin comes up. If I say T, test manager comes up. Or you can send the notifications to a group, for example, QA engineers. Or you can send it to a given email address. So this email address option is a good option because you can create a distribution list in your mail server. For example, if you use Office 365 or Google, you can create a group or distribution list, add people to it, and then put the email address of that distribution list in here, and then they will get emails. The benefit of using a distribution list over using the group is that a distribution list is more scalable and flexible. Groups will include users that exist in Bamboo, but with a distribution list, you can send emails to people who don't have a user account in Bamboo. For example, the boss of your company may never want to use Bamboo and never have a user in Bamboo, but they want to get notifications. So let's say we want to send to an email address, and that is user@example.com, and we click on add. Setting up notifications is highly recommended, especially if you want to know if somebody deployed to your production and things like that. Now, if I run this build, I should be getting a notification. So as you can see, I have a notification and you have a nice email. If you click on View Build button, it will take you to Bamboo and it will show you the details of the build. Your Atlassian Bamboo comes with a set of standard features, but you are not limited to those standard features and you can extend your Atlassian Bamboo. For doing that, log in with a user that has administrative privileges and go to your administrative page. In here, look for apps. As you can see, there is a section called Manage Apps with some options. The easiest option is to click on Find New Apps. In this page, you will see that there are a list of apps. By default, it doesn't show any apps. You better just change one of these options and then it will automatically refresh this page. And the list of apps come up. As you can see, some of them are free, most of them are not free and you have to pay and purchase licenses. After installing any of these apps, you will have access to an extra set of functionalities and I will show you some of the good ones. One of the really good ones is the AWS tasks. This one, tasks for AWS. If you heavily use Amazon Web Services, you will be deploying things to AWS and you will be using AWS services. Without having the tasks for AWS application, you will have to script everything like the ones that we did for deploying the AWS Lambda. With task for AWS, you will have access to many functions such as code deploy, ECS, Lambda, and SSM, and OpsWorks, and S3, and whatnot. And that makes deploying applications to Amazon Web Services very easy. Another good example is the addition of new notification channels. So as you remember, we only managed to set up an email server and use the email medium for sending notifications. But how about if I want to send notifications through Microsoft Teams or through Slack? If I search for Teams, you will see that there is a Microsoft Teams Bamboo connector. If you purchase this or install the free trial, you can send notifications to Microsoft Teams as well. Or if I search for Slack, you will see that there is a Slack Bamboo connector and that allows Atlassian Bamboo instance to send notifications to Slack. Again, as I said, if you search for example, highest rated and free, then you can see all the free applications and install them. One good free application is the Google Play Publisher. By default, Bamboo comes with 2 iOS tasks that allow developers to publish their iOS applications to testing environments, but there is nothing out of the box for Google Play. And if you get this free task, then you can deploy your Android applications to Google Play as well. I encourage you to have a look at different types of apps and see that which one will be useful for you and maybe use those. In this section of the course, we want to see that how we can leverage the power of Docker and containerization with Bamboo. There are 2 ways of using Docker with Bamboo. One of them is that we build, test, and package our code inside a Docker container and not directly on the build agent. This allows us to create a build agent or build environment when we need it and then destroy it when the build is done. And this capability potentially eliminates or reduces the need of remote build agents. Another way of using Docker is that we completely deploy our Bamboo and Bamboo build agents using Docker. In the next lecture, we want to explore the first option, which is the isolated build. In an isolated build, Bamboo server hasn't been deployed using Docker. It's deployed on a virtual machine or on a server exactly the way we have learned so far. For example, it's been deployed on a Windows machine. When we want to use Docker containers instead of a remote build agents, we need to have a local build agent instead, because without a build agent, it is impossible to start a build. So you need a build agent, and then that build agent will be configured to run all the tasks of a job inside the Docker containers. Depending on the type of the task, you can assign the task to different containers. For example, one task might go to a container that has Python, another task might go to a container that has .NET. When you use this setup, you must create your capabilities on the local build agent. However, you set the path to the tools on the Docker container. For example, if on the Docker container your .NET compiler is on /bin folder, but on your local agent it is set on /user/bin, you must use the /bin folder when you create the capability on the local build agent. And also, the local build agent, as you know, has a home directory. We normally call it Bamboo Home or Bamboo Agent Home. And the Docker containers, when they come to life, they share that folder. So they create a volume. In Docker, volume is like a disk that maps to that Bamboo Home folder. And therefore, when the Docker container creates artifact, the artifact will be dropped on Bamboo Home, and the local build agent will be able to see that artifact. And needless to say that in order to use this setup, you need to have Docker installed on the build agent. So if you use local build agent, Docker has to be installed on your Bamboo server's machine. If you do this setup for any reason using a remote build agent, your remote build agent must have Docker installed on it. I'm not going to show you how you install Docker. I'm going to assume that you have Docker installed already. So let's go to next lecture and then change the build plan that we created before and get it to compile and build the code in Docker containers instead of on the build agent. As I said, we want to work on the isolated build. The first thing you need to know is that Atlassian Bamboo comes with 2 Docker images, and we want to learn about one of them now. And that Docker image that we want to learn about is the Bamboo Agent Docker image. This is the base image for the Bamboo agent that you want to run as a Docker container. And this agent has these software packages installed on it. It's got JDK 11, it's got Git, it's got Maven and Python. So for example, if you have a Python code but it has a library, you can still use the Bamboo agent base image and then deploy your libraries as a local libraries, zip it with your code and use it as an artifact. That's one way. Normally, this is very limiting. You need more software to be installed on this Docker image, and therefore this image is called base, and that means that we need to create our own image on top of this, which is very easy to do. To create a new image based on this, we need a file called Docker file, and then we just run a command called docker build, and I will show you how we do that. To do that, you need to copy the name of the package. So we just click on copy, and then you need a Docker file. So a Docker file is like this. We created one before. So you say from, and then this Docker that I just copied on clipboard. So it's basically the same command. I have just deleted the Docker pull bit. So as you can see, these are same. So you say from that Atlassian Bamboo agent base image, you specify a work directory, and then you run some commands to install things on this machine. It's like installing packages on Linux. So first we say update this operating system and then upgrade it, and then we install things that we want using apt-get install. In this case, I have installed .NET SDK 7, and -y means that say yes to any questions. You can keep installing anything you want using apt-get. The Bamboo agent base image requires an environment variable called Bamboo server. If you use this image for building your code or testing only, you are not setting up the entire Bamboo ecosystem as a Docker. Just assign some value to this environment variable. It's not going to be used for anything. However, without this environment variable, the instantiation of this image will fail. So just have Bamboo server environment variable with some value. Now, when you have your Docker file ready, you can simply use a docker build command. Docker build. It's an option. You can provide a name, for example, Bamboo agent. And then -f Docker file. This is the name of the Docker file, and you must put a dot at the end, otherwise you will get errors. Now let's go to Docker and see the image. So as you can see, an image has appeared here. Optionally, you can say Docker image list or ls, and that gives you the image. So either you push this image to the local Docker. For example, if you have Docker installed on the build agent, you can just push this image to the local Docker like this one. Or you push it to Docker Hub. Or you push it to a repository that you have on Amazon Web Services or Azure or anywhere else. If you deploy your image to Amazon Web Services or Azure, your cloud provider, AWS or Azure, will give you a link for cloning it. Otherwise, you just put the image ID in a place, and then Bamboo will pull it either from the local or from Docker Hub. And I will show you how we do that. So first of all, let's do this. Let's go to Docker. So this is my local Docker. I will click on this run and I create a container out of it. So this is a container we created based on that image. So this is the image. This is a container I just created. In Docker Desktop, there is a terminal. We can basically log in into that machine. So I can do like ls. As you can see, I can run Linux commands. The .NET SDK is in here. It is in /bin. So that is what we use for the capability. So we go back. I just destroyed this container first. So we go back to Atlassian Bamboo. First of all, we need to go to our agent, local agent, and then edit the capabilities. For example, if the path of your .NET is different than /bin, you have to come here and set it to /bin/.NET, because that is where .NET executable file is. So as I said, you don't set the path of your capabilities based on the location of those tools, if they ever exist on the build agent. Rather, the path has to point to the location of that tool on the container. Once you have done this on your local build agent, we go to our plan. For example, I want to work with the sample app that was .NET, and then we configure the plan. And then you click on the job. So we do the isolated build on the job level. When you click on the job, you see these tabs. There is a Docker tab, and you need to say, I want Docker container, and then you put either image ID or the image name here. So because my Docker is local, I use the image ID that we see here. If you want to pull this image from Docker Hub, you need this name, Atlassian Bamboo Agent, this one. And then you need volumes. By default, volumes are mapped. So the working directory of the container is mapped to the working directory of local agent, and you don't need to change this. And we click on save. For now, I just disable the job for testing, so we don't test. I just want to build and create artifacts. So I just run now. So as you can see, it says agent is local agent. Without an agent, you cannot run this build. It just waits for an agent to become available. However, the build is happening inside the container right now. So it's not happening on the build agent. And build completed. If we go to Docker Desktop, as you can see, there is image, there is no container. And that was because Bamboo created the container, ran the build, destroyed the container. And this is very good, and this is one reason that I excluded the Elastic build agents and I removed it from this course. And that is because when you use this way of building, you really don't need Elastic build agents anymore. And this is quick and very cost effective, so you probably won't need a remote build agent either. In the next lecture, we will work on deploying the Bamboo ecosystem entirely as Docker. Now that we have gained some experience with Docker, we want to do a complete installation of Atlassian Bamboo server and its build agents using Docker. In this installation, we deploy the Bamboo server as a Docker container and not on a virtual machine or on a server. Every container requires a storage, and we call that a volume. Bamboo needs this storage for the Bamboo home folder or directory. So we will create a volume for Bamboo server that points to a folder or directory on a physical storage, for example, on a network or on your local machine. Then we deploy the build agent as a Docker container. The build agent also has its own working directory that we normally call Bamboo agent home. And therefore, the build agent will also have a volume that points to somewhere on the network or on a physical disk so that it can create the Bamboo agent folder and store files in it. And as you know, it's always the build agent that connects to the Bamboo server. You create this deployment in different environments in different ways. The way I will explain it in this lecture is for you to deploy it on your local machine. But you can learn the concept and do the same thing on Kubernetes or on AWS or on Azure if you deploy it for your production use. On a local machine, you need a file called Docker Compose. Docker Compose instructs the Docker engine about what sort of image has to be used, what sort of container has to be created, and also what is the networking between these different containers. If you just launched one container based on the Bamboo server image, this line, and one container based on the Bamboo agent image, this line, you would have two containers, but those containers couldn't communicate with each other. That is the Docker Compose that enables these two containers to talk to each other. As I said, if you use Kubernetes or if you deploy to, for example, Amazon ECS, the way you make these containers talk to each other is different. However, as I said, you are learning the concept and you can just replicate this concept in different environments. As you can see, every container is called a service under services. So we have Bamboo Server and we have Bamboo Agent. Each of these services or containers are based on an image. So in this example, I have used the base image of Bamboo Server and the base image of Bamboo Agent. In the previous lecture, you saw that we created a customized version of Bamboo Agent, and you're very welcome to use that. If you have that image on your machine, you can use the image ID. If it is in Docker Hub, just use the Docker Hub address, or if it is on some other registry, again, you just put the pool URL in here. Then you have a name for the container. Container name is important because it is used as your network address. So as you can see, I have a container name called Bamboo Server. And then in the environment variables of Bamboo Agent, I have used Bamboo Server like the name of a server or a location on the network. Docker will be able to use this service name or container name to resolve it to a network address. After that, we need to set environment variables. For the Bamboo Server, there is an environment variable that you have to set, and that is the server base URL. As you can see, I have used Bamboo Server. Bamboo Server will resolve to a network address and the default port is 8085. Then we have ports, and as you can see, I have said that the port on the container is 8085, but I'm going to access my container using 8086. You can set this port to anything you want. The next service is Bamboo Agent. Again, we have used the base image for the Bamboo Agent. It's got its own container name that you can again use as a network address. And there are 3 environment variables that we have used. The first one is Bamboo Server. In the previous lecture, I mentioned that if you don't have this environment variable, the container won't launch. And the address is basically the address of the server, which is Bamboo Server inside Docker with port 8085 / agent server. The second one is the agent home. That is the address of the directory where all the files are stored. And the third line is disabling SSL. When you deploy in this environment, you don't need the agent to be connected to server using SSL because both are in the same network. So it's a simple file. It would just take time to write it from scratch. So I have prepared it. It's on GitHub, and the link of this repository is also attached to this lecture. Now, to launch containers based on this, what you need is to go to terminal and be where the docker compose.yaml file is. As you can see, it's in the current folder. And then you just say docker compose up will launch containers -d. -d will detach this process from those containers. The images are getting pulled from Docker Hub. Okay, so as you can see, 2 containers started. Let's go to Docker Desktop. As you can see, there are 2 containers. One is the server, one is the agent. And we can go to 8086 port to connect to the Bamboo server. Obviously, the first thing it asks for is the license key. You have seen that how you obtain a trial license key before, so I won't show it. I just copy paste the license in here. Before you continue, there is something very, very important to set up here, and that is the URL by which the agent will connect to the server. We disabled SSL, so we cannot use SSL. You need to change this to TCP. Also, at the end, it says socket verify hostname false. This is relevant to SSL and not to TCP. You need to delete it. If you don't delete it with this ampersand at the end, your connection will fail because, as I said, that parameter is irrelevant to TCP. And then you click on continue. Now we set up the database. If your database is not the built-in database and you deploy Atlassian Bamboo for using in your team or company, you need to have a database installed already somewhere, and it has to be accessible from within the containers. So your database will have to have an IP or a DNS name, and that is accessible from the container. For this example, I use the built-in database. Then we just provide the username, password, and name and email. Victory 123 123. Full name Victory. at mydomain.com. I just wanted to put in something that we haven't used before. Now, the next step is to set up your agent. We go to Agents in Settings, Agent Authentication, Approved Access. This is the agent container trying to access the server. And then you just wait for a few minutes for agent to come up and become available. Let me refresh. So as you can see, now we have an agent, which is the container. As I said before, do not install the capabilities directly on the agent because Docker containers are unstable. They can disappear at any time. Instead, define shared capabilities by going to Agent Summary, and you see there is a link here. It says Shared Remote Capabilities. Start adding the capabilities here, because when a new build agent as a new container comes to life, it inherits all these shared remote capabilities. And that's a great way to make sure that if you lose your build agent container, when a new container comes to life, it will inherit these capabilities. In this lecture, we want to quickly learn something, and that is that we can combine the two approaches that we learned in this section of the course together, which means that you can deploy your Bamboo ecosystem using Docker. And also before that, we learned that you can deploy a Docker container that includes build agent on it and only spin it up when your build plan needs an agent. And then the build happens inside the build agent, and we call this an isolated build. The build agent that we just deployed for the Bamboo server, it can be used as a build agent by itself. It can also be used as a platform to launch extra build agents. But then those extra build agents will be transient. They will only come to life when we want to build something, and then they will be deleted. This approach is called Docker and Docker because build agent in here is a Docker container itself, but then we will install Docker on it so it can also create extra Docker containers, if that makes sense. So all we need to do is that we need to install Docker on that build agent, and that means that we need to create a custom image from that base build agent that Bamboo has. We have done this before. So if you remember, we had a Docker file that we used for the transient build agent, for the build agents that were launched by Atlassian Bamboo to build our code inside it. As you can see, it's installing .NET SDK. And if you want to install Docker on it, just say run apt-get install Docker. That's all you need to do. If you do this, next time that the Bamboo comes up, you can say that you want to build your source code inside a Docker image and then provide the image ID. Then this build agent will use that image ID to create the extra build agents for you. And this way, you are not going to install anything on a server or virtual machine. Everything will be in Docker. But also, you don't need to have like 10, 15 build agents in your Docker Compose. You keep your Docker Compose small and clean, but then you will create on-demand build agents using extra Docker containers.